What if I told you by the end of this video you'll have built 4 complete games in Python? A number guessing game that runs right in your terminal, a full ping pong game built with nothing but Python's Turtle module, a fast-paced fruit catcher built in Pygame, and at the end of this video, a complete platformer adventure with gravity, jumping, collectibles, enemies, and sounds. 4 games, 1 language, and we're building all of them in this video from scratch right now. Let's get into it. Guessing game. So I've created a folder and I've called it the secret number. And you can follow along in VS Code as well, but I'm using PyCharm IDE. So simply just create a new file. I'll call it main. You should type main.py. And in here, let me explain the game a little bit first. A guessing game needs 2 things, right? The first thing that it needs is a secret number itself. So a secret number itself, and it needs a way to guess that number. So just 2 things that it needs. And let's start there. So let's start at first by importing a module called random. So this is a module that gives us random numbers so that we can work with random numbers. And at the very beginning, what we want to do is we want to pick a secret number. So let's pick a secret number from 1 to 100, let's say. So secret equals to random.randint 1 through 100. So all this does, it gives us a random number from 1 to 100. Actually, I said 10, so let's actually pick 10 because it's easier. So secret will have either 1 or 10. So we can see the value of secret. So simply just print secret, and you can click play on top over here. Or what you can do is you can open up your terminal and you can do py main.py and it will run that application. So let's try running it a bunch of times. So we got 10 right there. Next, we got 3. We got 3 again. We got 2. We got 9. As you can see, we're getting random numbers. So secret is holding random numbers from 1 through 10. And that's fine. So now we need the player to guess a number. So we need a way for the player to guess a number. And to do that, first of all, we need to take user input, or guess in this case. So let's say guess equals to, and the way you take inputs in Python is simply just input, and then you want a string. So guess a number between 1 through 10. Let's say that for now. Now, since this by default is of the type string, as you can see, let me just print. Let me print the type of guess. So if I just run this program and it says guess a number between 1 and 10, and if I say something like 4, currently the type is string. And you really can't compare the type string with this type, because if you print the type of secret, and you'll see, so if I guess a number like 5, you can see the type of secret is int, and the type of our guess is string. So you really cannot compare string with an integer. And for that reason, we're going to convert this into an integer by simply just casting int on it. And that converts it into an integer. Now we have our secret and we have our guess. Now we need to be able to check the guess against the secret. And simply just to do that, let's write a basic condition first. If guess equals to secret, then simply just print you guessed correctly, right? And if we run this, guess a number between 1 and 10, let's say 5. Oh, we didn't guess it correctly. If we can put an else statement right here. So else, we can say print you guessed an incorrect number. Let's say that for now. And let's start it. And it says guess a number between 1 and 10. Let's say 3. It says you guessed an incorrect number. And you can keep doing this. Oh, I got it correct on the second try. So guess a number between 1 and 10. I guessed 5 and I guessed correctly. So you can keep doing this. Or sometimes, if you're guessing, then there's really no way of knowing what the number would be. So if I guess 4, I guess an incorrect number, but I don't know if the guess was higher or lower. So to do that, you can simply just modify these if statements. So instead of if guess equals to secret right away, let me delete this. Let me delete this away. So we can do if guess is smaller than our secret. So that means our guess was smaller than our secret. Our secret is larger than our guess. We're simply just going to print that our guess was too low. So let's say too low. Elif, we can do an elif statement. Your guess was larger than the secret. Then we can print too high, right? Else, we're going to print you got it. So you are right or something. Because if it's not smaller than secret and if it's not greater than secret, then it must be equal to secret, right? So if you run this program now and if you do something like 3, it said too high. So the number was probably 2 or 1. Let's do it again. Let's say 5. It said too high again. So the number was too high. Let's do 1. So it says too low. So the number was something above 1. And let me try to get it correct right there. So I got it correct. I guessed 4. It says you are right. But one guess isn't a game, right? Because you guess too low, you guess too high, and the game just ends and you have to restart your entire game. That isn't really fun at all. So we need to keep asking until you win. So let's do that in the next section. All right, so in this part, let's wrap our guess in a loop so that it repeats until you get it right. Right now, we check it once, and if it's incorrect, or if it's correct even, we just exit immediately. So what we want to do is we want to put all of this inside a loop. So I'll simply just start a loop right here, while true. So while true is an infinite loop. So create an infinite loop that keeps repeating until the player gets the number right. And I'm going to put all of this inside the while loop. So simply just tab it in to your while loop. And you can see that all of this will be inside your while loop now. But the downside is that even if you get it right, your while loop doesn't really end. So what we want to do is if we get it right, we want to break. So what this does is if we get the number right, we break out of the loop. Now, when we start it, we can start guessing our number. So let's guess 5. It said too high, so it has to be something lower. Let's guess 1. It says too low, so it's something between 1 and 5. Let's say 3. Too high, so it must be 1. It must be 2. And it says you are right. As soon as we write, our process exits with exit code 0. So we basically put it in an infinite loop that will keep on running, taking guesses until you get it right. Before we move on, we actually need to do some error handling because right now, if we start right now and if we say something like apple, it will give us a traceback and a value error. So it says invalid literal for int for apple because we take the input and we're immediately converting this input into an integer. And if that fails, we're not really handling that error. So our entire program just crashes. So instead of that, what we can do is we can wrap it in a try catch block. So what you can do is try, and we're going to try to do this guess. So I'm going to tab this in. So I'm going to try to do this guess. And if something wrong happens, I'm going to catch. I'm going to, you actually have to use except. So I'm going to catch using except, and I'm going to catch whatever we got earlier. So what did we get right here? The thing that we got was value error. So we're going to catch our value error. So if we get a value error exception, then we want to print that's not a number. Try again. Simply all we want to do. So what you do want to do right here is that if you guess and this succeeds. So if it doesn't go inside this block, that means that it has succeeded. How this works is it will take your input and then it will try to convert it to integer. Now, while doing that conversion, if it gets a value error, it will ignore everything else and just print out the statement and move on. If it doesn't get a value error, it moves on with the rest of our code. But we're still inside this try catch block. And if you hover over this guess, you can see that name guess can be undefined. So if this something goes wrong right here, this will just be undefined. That is why in here, if we have the correct guess, so if we get a valid number, then we want to break. So what break does is it breaks outside this inner try loop. So now when we start, if we type something like apple, it's going to say that's not a number, try again. But it's still guessing with it's still running the other conditions with our guess secret and everything. So all we need to do is we need to take all of this. We're going to cut it and I'm going to move it in here. Right after I do that, if I run this program and if I type something like apple, it's going to say that's not a number, try again. And I can continue guessing. So 5 is too high, 3 is right. So as soon as we get the right number, we again exit with the exit code 0. But right now, you literally have unlimited guesses. You can just sit here and keep on typing 10 forever without any consequences, or you can keep guessing every number. So 10, 9, 8, 7, 6, 5, 4, and you can get it correct like that. So you can brute force it. But in real games, you have something called live system. So let's add stakes in the next section. All right now you can guess pretty much infinitely. So I could do this 10, 9, 8, 7, 6, 5, 4, 3, 2, until I get the right number. And this is not really a fun game, right? Because there are no stakes, there are no lives. So we can add a live system. All we're doing right now is we're importing random, or we're picking a secret number. And while true loop, so this loop is an infinite loop, inside this loop, we're trying to convert a guess into integer. So if that fails, then we print out a value error. If that succeeds, then we look at the guess and we see if it's lower than secret. If it's lower than secret, we say the guess is too low. If it's higher than secret, we say the guess is too high. Else, our guess is just right. But there are no stakes, so this is going to run every single time since this is an infinite loop. What we want to do is add a live system. So let's say lives of the player, and let's say lives equals to 3 by default. And every time we get a guess wrong, so at the very top, I want to see, as soon as we make a guess, I want to check if our guess is wrong. So if our guess is not equals to secret, that means our guess is wrong. I want to do two things. First of all, I want to let the player know that their guess is wrong. But it seems like we already do that right here. So I can instead immediately say the number of lives that they have. So the lives that they will now have is lives. So if guess is not equals to secret, that means our guess is wrong. What I want to do first is I want to reduce lives by 1. So lives minus equals to 1. I'm reducing the number of lives by 1. And right after, I want to let the player know how many lives they have. So I'm going to print lives remaining, and I'm going to print the number of lives. So let's see how that looks right now. If I write 10, it says lives remaining 2, and our guess was too high. I say 10 again, our lives remaining 1, and our guess is too high again. If I say 10, then it says lives remaining 0, too high. But if I keep on guessing 10, my lives are going to go to the negatives. That's because we haven't actually done anything with our lives yet. So what we want to do at the very top is before we even take a guess. Before we take a guess, we need to see if the player has enough lives to even play the game. Does the player have lives to play? And we can do that by checking if lives is smaller or equal to 0. If this condition is true, that means the player does not have enough lives. The player has either 0 lives or a negative number of lives. If that is the case, then immediately what we want to do is we want to print game over, you ran out of lives. And right after that, I'll put in a break statement so that we immediately break out of this loop. The indentation was wrong. Okay, so that we immediately break out of this loop. So now when we start the game, and if I type something like 10, I'm using 10 a lot, but if I write something like 10, it says lives remaining 2, and our guess was too high. If I say 10 again, it says lives remaining 1, and our guess was too high again. If I say 10 again, this time it says lives remaining 0, too high, and it says game over, you ran out of lives. We can no longer just infinitely guess until we get the correct number. Right now, our game works pretty fine. We can guess a number between 1 and 10. It'll give us some input. It says, oh, I got it right on the first try. I guess 10. It did guess 10 after all. So we have a simple game with live systems and everything. But usually games have difficulties. What if I want to be guessing from 1 to 1000 or 1 to 100? And what if I want a varying number of lives? So like maybe I don't want 3 lives. Maybe I want 7 lives or 10 lives, or I want to change the number of guesses that I have. So let's simply, instead of hard coding it inside our code, I'll write a function for it. So the function is going to, so the way you write a function is def, by the way, and I'm going to write a function called get difficulty. And inside this function, so it's not going to take any arguments. And inside this function, I'm going to print a bunch of things to make it look nice. So I'm going to print in a new line. I'm going to say choose difficulty, and I'm going to give the player a bunch of options. So the first option that they have is one is easy. And let's say easy mode has, let's say 1 to 10. So that they have to guess 1 to 10. And they get 10 lives to do it. Let's not say 10 lives. 10 lives seems like a lot. Let's say they get 3 lives to do it. Then after 1 easy, let's say 2 medium. And in medium, you can tweak these values as you like. So in medium, let's say they have to guess 1 to 50. And they get 10 lives. And after medium, let's say a hard mode. And in hard mode, they have to guess 1 to 100. And they get, let's say, just 7 lives. And all we're going to do after this is we're going to take a variable choice. And we're going to take an input. So we're going to take an input of difficulty. Actually, instead of casting this to an integer, I can just directly use the input itself. So I'm going to say difficulty, and that will be the input. If our choice, so if our difficulty choice was 1, then I'm going to return a number. So I'm going to return 10, 3. If elif, or actually if, you can use elifs, but I think if is better, because if you return out of here immediately, none of the other if statements run anyways. So if choice equals to, let's say 2, then return 50, 10. And if choice equals to 3, then I want to return 100, 7. So the first value I'll return is to how much are we going to create that random variable. And the second value is the number of lives the player will have. And at the end, if none of these are right, so if the player chooses none of them, by default, I'm just going to return the easy mode. So I'm going to return 10 and 3. This should be pretty self-explanatory, but I'm going to explain it once more. So we have a function called get difficulty. We're going to call this function, and we expect this function to return with 2 values. The first value we're going to use to generate the numbers. So we're going to generate 10 numbers or 50 numbers or 100 numbers. And the second number is going to be how many lives that function, or like how many lives that player will have. So we have get difficulty right here. And right after defining the function, I'm going to call the function. So to simply call the function, I need 2 variables. Let's say max number, and let's say lives. So instead of manually creating this lives variable right here, I'm going to delete this. I'm going to say max num and lives. I'm also going to, equals to, I'm going to call the get difficulty function. So as soon as this function is called, the player will be prompted with these options, and we will take a player input, and we're going to get either of these values. We're either going to get 10, 3, 50, 10, 107, or we're going to get 10, 3. After we get that, so instead of picking a secret number from 1 through 10 by default, I'm going to pick a secret number right here. And it's not going to be 1 to 10, it's going to be 1 up to max num. So if the player chose easy right here, it would be 10. If the player chose medium, it would be 50. So 50 would come here, and I would generate a random number from 1 through 50. So from 1 through difficulty, let's say. Right after I do that, now to make the game a little bit more interesting, I'll just do print. I'm thinking of a number from 1 to, and let's say max num. And let me, outside the loop, print you have lives remaining. So these are the number of lives I have remaining by default. And now we should be able to play this game pretty rightly without doing anything else. So by default, so as soon as we hit this line of code, this function is going to get called. And since that function gets called, we get this menu. We get choose difficulty, where we can choose easy, medium, or hard. Let's say easy. So let's pick 1. And it's going to say, I'm thinking of a number from 1 to 10. You have 3 remaining. Okay, I just said 3 remaining. I should have really said 3 lives. So let me fix that right now. So you have 3 lives remaining. And let's start it. So let's say I want medium mode. I'm thinking of a number from 1 to 50. You have 10 lives remaining. And right here, I'm saying 1 to 10. So that is also a bug. So we should also go ahead and fix that. So instead of guessing a number between 1 to 10 right here, I'm going to use format strings right here. I'm sure you're familiar with format strings in Python. So I'm going to use a format string and I'm going to say max num. So that value right there. And now, finally, if I choose medium, then it says I'm thinking of a number from 1 to 50. You have 10 lives remaining, and this value also changes right here. Let's guess a number. Let's guess 25. It says too high, and I have 9 lives remaining. So let's guess 20. I'm still too high. Let's guess 15. I'm still too high. How about 10? Too low. So the number is between 10 and 15. Let's guess 13. It's too low, so the number must be 14. And it says you are right, and we have finished our game. Similarly, we can go on hard mode. I'm thinking of a number from 1 to 100. You have 7 lives remaining. Guess a number. Let's say 85. The guess was too low. Let's say 90. The guess was still too low. Let's say 95. Oh, I got it exactly right. So you can see how we're starting to make a pretty fun game with just basic Python scripting. Even without all of the comments, this program would barely even be 40 lines of code, and it's all pretty easy to understand. Okay, right now we've done a few things. We can start, we can choose our difficulty, and we have a working live system where it is tied to each difficulty. But our essential part of the game is score. We're not really keeping score. It doesn't matter if the player got it on the first try or the second try or the 10th try. It's still right. So right now we want to give score. So a way to reward players. If they get it in fewer tries, they get rewarded. And if they get it in longer tries, then they get less points. So what we want to do is we want to create a variable called score. So let's say score of the player, and score equals to 0 by default. So by default, the player doesn't have any score. If the player has lost, then also the score is just default. It doesn't really change. If the player guesses wrong, then the score stays 0 as well. But if the player guesses right, we want to give them a certain number of score. Now we could just do score plus equals to 1. And that means that we just increase the score by 1. So every time the player got it right, they would get 1 extra point. But we're not really rewarding the player for getting it in lower number of tries. So for that, let's do something like score equals to, and let's say lives. Let's tie to lives. So the number of lives the player has is directly proportional to the amount of score the player will get. Let's say lives times max number. So if we start right now, and if I went on medium mode, and let's try to run through it a few times. I have 10 lives remaining, and let's try to guess the number. Let's say 25, which is too low. Let's say 40, which is too high. Let's say 30, which is too low. 35, 32, and I got it right. Oh, I actually didn't print out the score. Let's print out the score real quick. So let's print out the score like so, and let's run through that again. So let's say medium, and I have to guess from 1 to 50. Let's guess 30. I am too high. Let's guess 20. Too low, 25. Too high, 23. You are right. So I got a score of 350. Now at this point, I had 7 lives remaining, and the difficulty was medium. So I had 1 out of 50 chance of getting it. So 7 times 50, I got a score of 350. Now, the more I guess quicker, so if I guess quicker, I'm going to get more score. If I guess later, I'll get less score. Now, 350 might be a little bit big, so I'm going to floor division this by 10. So instead of 350 right there, I would have gotten 10 score. So the number of lives I have, for example, I have 3 lives remaining, and it was on difficult mode. So it was on hard mode. On hard mode, I have 100 guesses. So it would be 3 times 100 divided by 10, which would look something like 3 times 10. And I would get 30 points, right? Simple as that. But right now, you really cannot view the score. So currently, you have a score of 0. If you run out of all your lives, so if I start right now and I go on easy mode and I choose 10, 10, 10, I ran out of lives, but I couldn't see my score at all. So instead of printing out score in the middle right here, you can always print out the score at the end of this while loop. So as soon as this while loop ends, our game ends right now because there's no code beneath it, but I can do something like print your final score was, and then print out the score. So in this case, even if I fail, so if I get 3, 3, 3, it says game over, you ran out of lives, your final score was 0. And I actually want to make this game over, print in a new line so I can see it better. So let's start it again. And if I said easy, I'm thinking of a number from 1 to 10. Let's say 4, 4, 4. It says the game over, you ran out of lives, your final score was 0. Also, guess a number should also be on a new line, I feel like. It'll look a little bit better. 10, 10, 10, 10, 10, 10, 10, 10. I feel like medium has a lot of guesses. Okay, so I can guess 10 times, and this looks a lot cleaner. I have a live system and a feedback system, and at the end we do have our final score was 0, so we have a score system as well. All right, so currently we have a pretty solid game. So you can have a difficulty level inside which you have different numbers of guesses and you have different number of lives. And you can keep on guessing. So I'll try to guess this number. 10 was too low, 20 was too low, 30 is too low, 40 is also too low. How about 45 is too low? 49 is too high. So 47. And you have a score system. So your final score was 20. But currently, if you restart the game, so if you start up another game, there's no way of keeping track of this score. This score simply just gets removed every time you restart your game. So what you want to do is you want to be able to save your high score. And the way we're going to do that is we're going to save it in a file. So at the very top, I'll define a high score file, and I'll just say it's equal to highscore.txt. So a file called highscore.txt. And I'm going to write two functions. So one is this loads the score from the file. One, this puts a score into the file. So to load the score from the file, I'm going to create a function called defining load high score. So this is going to take my file and this is going to load the high score from that file. So I'm going to do a try catch block again. So try except block. And inside try, I'm going to open a file. So the way you do that in Python is you do with open and you open the file name. So it's inside high score file. So it's highscore.txt. I can change it right here. And I'm going to open it as f. I'm going to return f.read. So I'm going to read whatever is inside this file, and whoever's calling this function, I'm going to give them whatever number we have inside this file. But currently this will be a string, so I'm going to convert it into a number using int, as simple as that. Now, what are the things that can go wrong here? Well, there are two things that can go wrong. One is the file not found error. This means that the file doesn't exist. Or another thing that can go wrong is the value error. So if either of these things go wrong, let me put them inside brackets. If either of these things go wrong, I'm going to return 0. So there is no high score. I'm just going to give 0 as a current high score. Next is to save high score. So I'm going to save high score. And this will take in a value of score. So whatever value I give it, it'll store that inside the file. And again, we have our same structure. So we're going to do a try catch. Actually, try except. Cut this part out. And inside here, I'm basically going to open the file with open high score file. But instead, this time I was opening the file as read only. So since I'm reading a file, if it doesn't exist, I cannot read from it. But if I want to open a file in write mode, this means that if this file doesn't exist, it gets overridden And if it exists, all the contents get overridden. If it doesn't exist, a new file gets created. And if it exists, all the contents get overridden. So W as F, and I'm going to F dot write, and I'm going to simply just write that score. Now, since the score is an integer, I'm going to convert it into a string before writing. So when I write, I convert it into a string, and when I read, I convert it to an integer. This is a good practice because it's much safer to store your file with values that are strings than integers. Right, so I made two functions. One loads the high score from the file, and one saves the high score into the file. Now, when to do these two things? Currently, let's look right here. When we win, we want to check if our score is greater than high score. So we want to check if we achieved high score. Did we get a high score? So if score is greater than load high score. Load high score will give us the current high score since it reads from this text file and then gives us the current high score. If it is greater, then all we want to do is we want to save high score and we want to pass in our current score. So our current score is passed in and it's going to write that score inside the file. It's going to override any previous values. So this is pretty much all we need to do. If we scored high score, then we save it. At the very end, or actually at the very beginning and at the end. Okay, so at the end, I want to add a print statement that says current high score, and I'm just going to print the current high score. So load high score. If the player got a high score in this run, then current high score and your final score would be same. So these two values would be same. And also at the very top before our main function runs, I also want to print current high score right here so that it's much more, it looks nice for the player. So current high score, I'm going to load high score. Now, if you start up the game, actually, we need to put this before the statement that calls this function. So right here. And now if we start up the game, not right there, it should be right here. Okay. Finally, if we start the game, we get current high score is 0 because there's no high score. And you'll notice that a file has been created. A file will be created here called highscore.txt. It has nothing inside it currently. So let's come in here and let's play a game. So I'm thinking of a number between 1 to 50. Let's start guessing. So 30 was too high. 20 is too high. 10 is right. 10 is exactly right. I had 8 lives remaining, and 8 times 50 is 40. It's actually 400 divided by 10 would be 40. So current high score is 40, and my final score was also 40. Now, if you look inside the highscore.txt file, this 40 high score has been saved. So if you start your application again, you can see the previous high score was 40. And if I play another game, hopefully I can get a better score. So I'll do 30, too high. About 20, too high. 10 was too high. 5 is also too high. 3 was right. Okay, so I didn't get the high score. My final score is 30, and the current high score is still 40. The current high score inside this text is still 40. And that was our number guessing game, which is level 1 of this video. We'll create a new Python file called Pong. We want to create a Pong game. Before we start, let's plan out our game. So what do we want? I want a Pong game. For my Pong game, for example, I want my screen width to be 800 by 600. And I want a black background. We already know how to do this. You can just go ahead and replace that comment with the code if you know how to do it. We need a few objects inside our game, right? There's a few things that a Pong game needs. The first thing is paddle A. So this is the paddle that will be on the left side. Let's say this is player 1 and controlled by W and S. So if I press W, the paddle goes up. If I press S, the paddle goes down. Next, I want to create a paddle B, and the paddle B is going to be on the right side, controlled by player 2 and controlled with up arrow and down arrow on my keyboard. Next, obviously, in a paddle game, you need your ball. Your ball just bounces around the screen automatically. It just keeps on bouncing around the screen. If it hits a paddle, it'll bounce against the paddle. The last thing I need is a scoreboard. which keeps track of player score on top of the screen. So with the knowledge that you have, you should be able to create all of these yourself, but I'll just help organize your idea. Well, our logic is pretty simple. Ball moves every frame, and this has to be automatic. Next thing is ball has to bounce off other walls. This is also pretty straightforward since we can just change the direction of that ball. Then ball bounce off paddles. So not of, it has to be off paddles. Our ball has to pass left wall. So if left wall, then player 2 scores. Since player 1 is supposed to be guarding the left side, if our ball goes through the left side, our player 2 should get a point. And ball pass right wall, player 1 scores. That's pretty simple. And the last thing we need to do is update our score on top. So this should be the entire logic, all of the games and the entire logic of our Pong game. Now let's start creating it. So at the very beginning, I'm going to import Turtle and I'm going to set up my screen. So the way we did that earlier was we created a variable screen and then initialized it with turtle.screen. We called turtle.screen. Right after it, let's set our title. So screen.title, and let's set it to something like Pong. And set our screen.bg color, which we wanted to be black. Next, we wanted screen.setup. We wanted our screen to be 800 by 600, so we can set the width and height like so. And screen.tracer is a special property that we're going to set to 0. This is a new property. All it does is it turns off animations. So you can write turns off animations. By default, Turtle will, while drawing and moving around, it will show you animations every time it moves, even if it's at the max speed, which is 10. So if you just do tracer 0, then it will just stop Turtle from drawing those animations. Next, I want my scores. So by default, I'll have 2 scores. Score for player A. So player A is going to get 0, and score for player B. Player B is also going to get 0. Pretty simple. Now I'm going to start by drawing my paddle A, which is the paddle on the left. So paddle A is a turtle. This is a turtle. We know what this does. We want my turtle speed to be 0. I don't want any of those drawing animations. Paddle A dot shape. I want it to be a square. So by default, the shape of our turtle, or the shape that it draws by default, is just a line. But instead of that, it's actually a triangle which draws a line. But I want the shape of my paddle itself to be a square instead of a triangle. And we'll see what that means in a bit. I can change my paddle A dot color. Obviously, we need a white color, otherwise everything is not visible. Then I can set the size of my paddle. Currently, the size of my paddle is very thin. It creates a very thin line, but I want to create a pretty thick line. So I can do paddle A dot shape size. And let's say the width. So stretch width. Stretch width is going to be 5. So it is going to be 5 units long. And stretch length 1. So it's going to be 1 unit like long lengthwise and 5 units wide widthwise. So since I want to draw my paddle, I'll just move it up and down. I don't need to move it left and right to draw that paddle. And you'll see what that means in a bit. So paddle A dot pen up by default. By default, I don't want to be drawing anything until I go to the location where my paddle spawns. So my paddle is going to start at minus 350, comma 0. This is where my paddle is going to start. So again, line by line, we created a turtle for our paddle. We set its speed to the maximum possible, which is 0. After 10, it is 0. Then I set the shape to be square so it doesn't look like a triangle. It draws in white color. And it is 5 units wide and 1 unit long. So whenever it moves, it's going to create that. Currently, I don't want to draw anything when moving. And I go to my starting position. And now I am ready to move. I'll create the same for paddle B. So paddle A. And then I'll create my paddle B. Simply instead of all these A's, this is all going to be B's. And instead of going to minus 350, I'm going to positive 350. Everything else is the same since they're both the same paddles. At the very end, I want my ball. So my ball is also going to be a turtle. So turtle dot turtle. And the ball speed, obviously all of our speeds are 0. Our ball dot shape, I want it also to be a square. You'll see it in a bit because circles are hard to work with. Squares are much easier since collisions are easier. Then I want my ball color, obviously, to be white because I want to see it visible. I'll do pen up for now, and then I will go ball.go to 0, 0. The next thing I want to do is that I want to move my ball. So by default, my ball should be either moving in the y coordinate or the x coordinate, or sometimes both of those coordinates. So we can add custom attributes that can move the balls throughout horizontally and vertically every frame. So simply doing ball.dy equals to 0.4. And next, to move it across the y-axis, and ball.zx also equals to 0.4. So it's going to set a 0.4 strength for it to be moving in that axis. And you'll see what that means once I start the application. Finally, I want the scoreboard. And the scoreboard, would you guess it, will also be a turtle. Turtle.turtle. And the speed is also going to be 0 because I don't want to see any animations. The color is also going to be white. It is going to dot pen up for now. And it's going to hide our turtle because I don't want to see that triangle, or I don't want to see a box or anything for our scoreboard turtle. Then scoreboard.goto, I want to go to this location, which is 0, 260, right on the top of our screen. And we will write what we wrote earlier, but this time with variables. So I can do something like an F string. And inside my F string, I can say player A has the score of player A. Player B has the score of player B. Simple as that. And we're going to align it to the center. And that is all that we'll do for the scoreboard right now. Finally, we have our keyboard controls. So keyboard controls. And keyboard controls are pretty simple. We've already done this before. I explained this in the previous episode. So paddle A, we're going to get the current y coordinate of paddle A. So paddle A dot YCOR. And one extra thing that we have to check, so I'll show you that as well. At first, we need to move the paddle A y plus 20. So we can move it up by 20. Now I'm getting an error. Returns the turtle's y coordinates, no arguments. This works perfectly fine. But for example, if our paddle is way above the screen, we don't want it to go off the screen. So if we're close to the edge of the screen, we don't want to move further up. For that reason, all I will do is I will do if the value of my y is greater than 250. Actually, if it's smaller than 250, then only let me move. So if it's greater than 250, that means if it's off the screen, then don't let me move. And I'll simply copy this code and I will paste it for all of the controls. So paddle A, this was paddle A up. Then I can have a paddle A down where I reduce this by 20. And actually, I need to check if it's not smaller than. I need to check if it's greater than minus 240, for example. So if it's greater than minus 240, that means it's still on the screen and I want to remove it. I want to move it down. So paddle A dot, this needs to be set Y. This also needs to be dot set Y. Next, I will do the same, but for paddle A right. So for right, I'm going to get my X coordinate, X and X. I'm going to dot set X, and I'm going to increase X by 20. But one thing that I have to check is if the value of my x is smaller than 250, which is completely fine. Yes, it needs to be. Next, if I'm going to left, so paddle a left, I'm also checking my x coordinate, but it has to be greater than minus 240. So it has to be greater than the negative most value to be still on the screen. And if that is the case, then I reduce the value by 20. Actually, looking at this now, I don't think we need to go left and right on the paddles because the paddles just move up and down. So instead of paddle A right and paddle A left, we can remove this portion and we can copy this and we can do the same for paddle B. That is my bad. So we can get paddle B and move paddle B instead of paddle A. So actually we don't need to go left and right. So we actually don't need to deal with left and right controls at all. At the very end, we have our final keyboard bindings. So keyboard bindings, which is pretty simple. We do screen.listen, which we've already done before. Screen.onKey, we can look for paddle B A up. So if I want to go paddle A up, then I would have to press W. If I want to go paddle A down, then I have to click on S. If I want to go paddle B up, so if I want to go paddle B up, I have to press the key up. And if I want to go paddle B down, I have to press the button down. And that is as simple as that. I also want to update my screen constantly. So to do that, I'm simply going to start up an infinite loop and then do screen.update. So this will update my screen throughout. So each iteration is one frame of the game. Since we set the tracer to 0 earlier, that means that nothing gets drawn automatically. This line manually triggers a full redraw of everything on the screen. Once you call it per frame, the game animates pretty smoothly. Inside this loop, before our screen.updates, what I want to do is I want my ball to be constantly moving. So ball.set x, I want to get the x coordinate, and I want to add the value that we set earlier, so .dx to it. Also ball.set y, I'm going to get my y coordinate and I'm going to add the dy. So on top, if you look at where we define the ball, we have the y value changing, which is 0.4, and the x value changing with 0.4. So all we're doing is that we're changing it right here. So this is where it's actually changing. Next, we want to check if the ball is colliding with anything. So if it's colliding with the top and bottom walls, we need to stop it. So if ball.ycor is greater than 290, that means it's colliding with the top wall, then I want to set my y back to 290 since I don't want to go it above the screen. And I'm going to set the dy, so the direction it's moving, to -1. So if it's moving upwards, it's now going to move negative, so downwards. If it was moving downwards, it's going to move negative upwards. It's just going to get multiplied with wherever it's moving, so it goes in the opposite direction. And same for the bottom. So this was for the top. For the bottom, I need to check if it's less than -290. And I'm going to set it to -290 and also reverse the direction. So this is reversing the direction. This is setting it to a certain location so it doesn't go off the screen. All right. Next, I have to check if the ball went to the right of the screen or to the left of the screen. If that happens, then player A scores or player B scores. So if the coordinate of my ball.xcor is greater than 390, that means that it has gone to the right of my screen. So it has passed the right of my screen. That means player A, which is on the left, has scored and player B failed to defend. So ball.goto, I want to reset the ball, make it go back to 0, 0, and set its dx to -1. So now it's going to move moving in the other direction. So it's going to be moving back to player A. Then I want to reset the score, or actually increase the score. So the score of A is going to increase by 1. So wherever A is, I don't think it was score A, I think it was player A. Player A is going to have 1 extra score. We're going to call scoreboard.clear. This basically means any previous text or anything drawn by this turtle is going to get cleared. So the previous score is going to get cleared off the screen. Basically, this text is going to get cleared off the screen, and I'm simply going to paste it again, and we're going to rerun that write so that now we get the proper score, the updated score. And the same thing is going to happen, Control C, and we can paste it, because the same thing is going to happen if player B scores. But this time, if it goes less than negative 390, that means player B has scored, and this needs to be multiplied. So this needs to be multiplied. This time the score of player B increases by 1. And everything is pretty simple. All of this logic is pretty easy to follow and understand. Lastly, we have to check collisions for our paddles. So paddle collision. If ball.xcor, if the coordinate of our ball is greater than 340, that means it's to the right of our screen, and ball.xcor is less than 350. So that means it hasn't gone off the screen, and that means that it hasn't gone off the screen. And we have to check a few more conditions. We have to check if ball.ycor is less than paddle b.ycor and plus 50 actually, plus 50, and ball.xycor is greater than paddle b.ycor minus 50. So I'll simplify that expression a few times. So it might look a little bit complicated, but it is the most simple this expression can be. And we do not open brackets, we just give an indentation. I will move this up one line. I think we can further simplify this. So I'll remove this parenthesis, and inside I will write. So all I'm checking is that the ball is in the range of the paddle. All this condition, this huge condition checks, is if the ball is within the range of the paddle to be hit by it. If it is in that range, then I want to change a few properties on that ball. So the y coordinate has to be, actually the x coordinate, set x, has to be negative 340. So it has to be set exactly where the paddle is. And the dx has to be multiplied by negative 1. That means the direction of the ball should be now opposed, or it should be facing the other way. Actually, I think this is positive 340. And next, we're going to do the same thing, but we're going to check negative 340 for less than. And we're going to be checking negative 350 also for less than. And ball.set x is going to be negative 340, and ball.dx is set minus 1. Now we can start this application and finally see our game running. Our ball currently is stuck on the left side of the screen, so we're going to start with the ball's coordinate setting to 0, 0. We can go all the way up here and we can see that it is set to 0, 0. So we must have some problem in our collision. Okay, all we had to do was fix this condition right here. So fix it and set it to this. And now we can start our game. I can see that the ball is moving pretty fast. So let me reduce that speed. We're moving by 0.4 every frame. So we can reduce the speed. This depends on your computer cycles as well. If you have a faster CPU, then the ball is going to move faster for you. If you have a slower CPU, then it's going to move slower. So I can set it to 0.1 and I can move my paddle. So I can move my paddle to intercept it, and if it does intercept it, then it does bounce over. And if it does intercept, it does bounce over. And that is the simple Pong game made using Turtle in Python. All right, now let's get started on level 2. So in level 2, we'll be making a catch game. So items will be falling from the top and we're going to catch it, as you saw in the demo earlier. So we're going to set up using Pygame. So the first thing that I want you to do is open up your terminal and go ahead and type pip install pygame CE. So if you're running an older version of Python, just pygame would be fine, but I recommend everybody just use pygame community edition. And once that's done installing, we can continue. So at the very top, I want to import my pygame module and I want to import my random module. So we've already gone through what random does, and Pygame is what we'll be discussing in this part. We also have a complete video tutorial on Pygame. So if you want to look at that, then click on the iCards in the top right corner of your screen right now. So the first thing that you need to do is initialize your Pygame. So simply to let your program know that we're going to use this, we're going to do pygame.init. Nothing will appear yet. We haven't created a window. That's what we're going to do next. So let's create the game window. We need to define its width and height first. So game window creation. We need to define its width and height. So width would be something like 400 and height would be something like 600. I'm using all caps so I can reference them throughout the code without getting confused and without having to use numbers every single time. So width and height will stay constant throughout my game. So this will look like it'll be longer on the vertical side and shorter on the horizontal side. So it'll be 400 pixels wide and 600 pixels tall. Now we'll finally create the screen. So to create the screen, simply just screen equals to pygame dot display dot set mode, and we're going to give in a tuple of our width and our height. So this will create a Pygame screen. Now we can start this application. So when we start the application, you'll see the screen flash for a very brief moment and then exit right away. That's because we don't have our game loop yet. So we'll be creating that as well. So this is our main game screen. This is where we'll be doing everything. We'll be putting things on the screen. We'll be taking things off the screen and everything like that. Next, we can set a title for the screen. So set a title for the screen just for it to look nice. We can do pygame.set, actually pygame.display.set caption. And let's set it to something like catch the fruit for now. Next, we're going to use a clock. So the concept of clocks you'll come across this a lot of times. Basically, in any game, you want to limit the maximum amount of FPS that you have. You either want to set it to 60, 120, or something like that. The default that we like to use is 60 because some computers might run the same game fast and some computers might run it slower. So in some games, your fruit might be falling faster, and in some computers, your fruit might be falling slower. To prevent that, we're going to use a clock, and I'll show you how to use a clock as well. For now, just use pygame.time.clock. So we're going to create a clock like so, and we're going to use this clock inside our main game loop. Next, we need a font. So our score text and everything needs to have a font, and we're going to create it right here, which is simply just pygame.font.systemFont. And we're going to use the default font, so I'm going to pass in none. If you want the custom font, then you'll pass in the name right there. And I want a size of 40. Next, we'll be using a bunch of colors throughout the game. So our falling fruit might have a different color, our background has a different color, our font has a different color. So I just want to define all the colors that we'll be using in our game in one spot so then I don't have to keep on, giving the colors again and again. So I'm going to say white. White is simply a tuple of 255, 255, 255. Then I'm going to say BG for our background color. I'm going to use 30, 30, 40. So background color is like a dark blue gray. I'm going to have a green color defined. So I'm going to use this for my basket or my paddle. So 80, 200, 120. And then I'm going to have red for my fruit. And I'm going to set it to 220, 80, and 80. So I can set this individually when I need it as well, but setting it right here just makes it more convenient for me so that I can access it later on without having to type these numbers out every single time. So after I'm done with that, I'm actually also going to have a score system in this game. So like we did in the previous game, we're going to set a high score. So our high score is simply just going to be a file. So it is going to be high score
file, and I'm going to set it to highscore.txt. It is simply just going to be high score file. It is simply just going to be a file, and instead of having, I can change the high score file right here, and it'll change throughout my program. All right, now I'll create two different functions. One is to load the current high score, and one is to save the current high score. Save, or let's say save the new high score. So at the beginning of every game, we want to load the high score so that the player can view it. And at the end of that game, we want to save the high score so that if the player has achieved a new high score, it shows up in the next game. So to load the current high score, I'll create a function like I did earlier. So defining load high score. And you must be familiar with input-output syntaxes or file reading with Python because you'll do this a lot. So you'll always have your try block and you'll always have your except block. Your exceptions will usually differ, but I'm using file not found error and value error. If I get either of these exceptions, I'm just going to return 0. That means if the file doesn't exist, or if I cannot read what's inside the file, the high score will just default to 0. Then in try, I'm going to actually open the file. So the way you open file is with open. You give in the file name, which is inside my high score file variable, and you give in a variable. So you give it a temporary variable to use. So I'm going to return f.read. So my file is f, and I'm going to f.read and return whatever the value is inside there. But I'm going to return it as an integer because I want to be able to compare the high score with my current score and stuff like that. Next, saving a new high score. So simply in this file, I'm going to save the current score. So defining save high score, and this is actually going to take a score. So whatever score we pass when calling this function, it is going to put that score inside our file. So again, it's going to with open our file. So I'm going to open the high score file, but by default, I'm not passing in a second argument. So it's going to open it in read mode, but I want to open this file in write mode. So the file already exists. It's just going to create a new, override that file for me. And if the file doesn't exist, it's going to create a new file for me. So as f, and I'm simply just going to f.write, and I'm going to write in score. But score right now passed in would probably be an integer. So I'm going to convert this into a string before storing it, because strings are much less susceptible to being corrupted when stored in files. So that is what we're going to do. So we have our load high score function that loads in a high score from this file, and we have our save high score function which saves in the high score. Going to create some game state variables. So I'm going to name them game state variables. So these are everything that you have on your screen, right? Like your basket, your fruit, the speed that your fruit is moving at, your scores, your lives, and everything. So at the very beginning, I'm going to create my basket. So my basket is going to be a pygame.rect. Pygame.rect is how you create a rectangle in Pygame, and we discussed about this in our Pygame video. And I want to center this rectangle. So I'll give it a certain property that is going to center it real soon. My second value is going to be the height. So the way this works is x and y is the position. Then you give in your width and you give in your height for this rectangle. My x, I want my basket to be centered at the screen when I start it. My y, I want it to be towards the bottom of the screen. Width and height, so I want it to be longer, so more girthier than it is taller. So in my width, I'll give it something like 80. So it's going to be 80 long, 80 pixels long, and it's going to be 20 pixels high. So it's going to look like a basket. As for my x and y, my x needs to be centered. So the way I'm going to center my x is I'm going to use this width variable that I have right here. If I set my x to 200, then of course it's going to be centered because 400 is the full width and 200 will be half of that width. But imagine I change this width, then it won't be centered anymore. So I'm going to tie it to that variable. So I'll do width, floor division it by 2. So I have to pass in an int, by the way, to create rectangles, you have to pass in integers. That's why I'm floor divisioning it so that I get an integer. So if I change my width to 800, my center is still going to be 400. But since Pygame spawns in rectangles from the left side, I'm actually going to start drawing a rectangle from the middle. So my basket is going to be a little bit to the right. So I need to reduce the number of my half of my width. So if I reduce half of my width right here, it is going to center it perfectly. So half of my width will be to the left side of this, and half of my width would be to the right side of this. And for my height, I can take that height again. If I just put in height, it's going to be at the bottom of the screen, touching the bottom. So I want it a little bit higher, so I'll do height minus 40. So my basket in total is going to spawn at the middle of the screen. So centered in the middle. It's going to spawn at the bottom, like 40 pixels above the bottom. It's going to have a width of 80 and a height of 20. Next, my fruit. So whenever I spawn in my fruit is also going to be a rectangle in this case. Whenever I spawn it, well, the X position has to be different, right? So when the fruit falls down, I don't want it to fall down at the same spot. I want it to fall down from different spots. So that's where my random library comes in. So I'm going to create a random.randoms, and it can be anywhere from 0 to width. So anywhere from the leftmost to the rightmost of the screen, my fruit can spawn in. But since my width, if I just put in width, it might spawn in to the right of the screen. So I'm going to do width minus 20. Right after that, I have to set a Y value, which I'm just going to set 0 because I want it at the top of my screen. And I have to set in a size for the actual fruit itself, which is 20 by 20. So the fruit is 20 pixels tall and 20 pixels wide. It's going to start anywhere from the leftmost to the rightmost of the screen. It's going to start at the top, and we'll do some stuff to move it down later. And now is our game variables. So game variables. For our game variables, you might have something like fruit speed. So fruit speed by default, let's set it to 4 pixels. Next, you might have your score. By default, it'll be 0. Let's set lives to 3. By default, game over would be false because game would not be over. And by default, your high score would be load high score. So we're going to load the high score and then put it into this variable by default. Okay, so now currently we have a bunch of things, but none of them are actually tied to a screen, or we cannot actually see the screen right now. So I'm going to set that up right now. First of all, I want to set a variable called running equals to true that just says if our game is running or not. It's different to game over because even if game over is false, or even if we are at game over, so even if game over is true, running still might be true. Running doesn't set to false unless you exit out of the game. So while we are running, so currently it's an infinite loop, first thing we need to do is handle events. Next thing that we need to do is update game state. And the third thing that we need to do is draw everything. So handle events means anything like left mouse, right mouse, and all. Update game state means all of these variables. So moving these on the screen, you're going to update it and draw everything. So after you update it, you want to draw it onto the screen. So after we do all of that, we're going to pygame.display.flip. Now all this does is any change that you've made throughout the execution of this loop is going to make sure that all of those changes are shown onto the screen. And finally, we limit our FPS. So remember how we created a clock on the top here? Well, we're going to use that clock. So we're going to do clock.tick 60. So it's going to take 60 times every second. And that is the maximum speed that this loop is going to run. So this loop can only run 60 times every second, or you'll see 60 frames every second. And right at the end, so right outside the loop, as soon as we exit the loop, I want to do pygame.quit. So that every time we exit the loop, every time we exit this loop, every time we set running to false, we're simply just going to pygame.quit. Now we actually need a way to exit the game. Right now, you cannot really exit the game. If you started this up, your screen would freeze. So inside our handle events, we're going to start to add our first event. So for event, we're going to create a for loop in pygame.event.get. So pygame.event.get returns us with a bunch of events that Pygame has, and we're looping through each of those events. We're going to pass for now, so we're going to add these events later. But one thing that I want to add is if event.type equals to pygame.quit. That means if the event type is quit, that means either Alt F4, Control W, or if you press the close button, then I'll set running equals to false. I no longer want to be running. When I said running equals to false, it's simply just going to call pygame.quit. So if I start it now, I have this catch the fruit window. And this window actually runs. It has a black screen right now because we haven't changed anything with the screen. But all we did was made this window. There's a bunch of variables loaded right now. And if I press this cross, we call pygame.quit and we exit the game. The next thing I want to handle is, bear with me, this might be a little bit vague for you, but the next thing I want to handle is events. So this is the quit event. The quit event, if a player wants to quit the game, we'll call this event. The next event that we're going to add is the game reset event. That means if event.type equals to pygame.keydown. So if we've pressed a key, and we're going to check a bunch of other things. If game over. So if the game is over and event.key equals to pygame.key underscore space. So let me go over what we just typed right here. The first thing that you need to check is if we're pressing a key. If we're pressing a key and our game is over and the key we're pressing is space, that means our game has ended. Our player has lost or our player has won, and we're pressing the space key. If we do that, we want to restart the game. But before restarting the game, the player might have had a different number of lives when they ended. The speed might have been different. They might have a different score. So we want to reset all of these variables so that the player can start fresh again, right? So we're going to reset all of these scores. Score equals to 0, lives equals to 3, fruit speed is going to back to be 4. Our fruit right here might be changed. So like the position of this fruit might be changed. So we want to reset the position as well. So fruit.x equals to the x value that we gave in right here. What was the x value? It was this. So I'm going to copy this. Fruit.x is going to be that value. Fruit.y is going to be 0. We're going to start at the very top again. And game over is now going to be false because when the game ended, it was game over. So game over was true. But when we reset, our game over has to be false so that the player can play again. So in this part, I want to add my player and I want to see it moving. So if I run it currently, we don't see our player, we don't see anything, and they're not moving at all either. So under my draw everything, currently, I just want to draw my player. So I'm going to pygame.draw.rect and I'm going to draw my player. So the first argument I take is screen. So screen is where I want to draw my player. This is the screen that we made at the very top. The second argument is which color I want my player to be. So I want my player to be the green color. And we've defined the color at the very top too. So we've defined what green is and the actual rectangle that I want to draw. So the rectangle I want to draw is my basket right here, the basket that I created. So I'm going to take this basket and I'm going to draw them on the screen. So if I start the game now, I can see a green colored rectangle drawn on my screen. It is exactly to the center. It is 40 pixels to the left, 40 pixels to the right, and from the bottom, we're 40 pixels up. But right now, even though I'm pressing E and D, my player isn't really moving. I want my player to be moving. So to do that, it is pretty simple. All we do is change the X position of the player. To change the X position of the player, I'm simply going to come right here. And inside this event.type pygame.keydown, I'm going to check a few things. So if I only want to run, so I only want the player to be moving if it is not game over. So if not game over, and I want this to be outside my game reset event, and I want it to be outside my for event as well. So at the very root, I want it to be just inside my while loop. I want it to be outside everything else. So I don't want it to be inside this structure. If not game over, we're going to get our keys. So pygame.key.get underscore press. We're going to get all the pressed keys at the current moment, whatever we're pressing. If the key that we're pressing is pygame.k underscore left, so if the key that we're pressing is the left arrow, then our basket that we have right here, I want to set its x coordinate to minus 6. So I reduce the x coordinate by 6. when I reduce the x coordinate, it's going to move left. If I increase the x coordinate, it's going to move right. So if keys, so I can copy this down again. Instead of k dot left, if it's k right, then I want to increase the x coordinate by 6. Now, if we run the game, this should work. So I'm pressing left, the x coordinate is moving left by 6. If I press right, it's going right by 6. But the problem is that every time we move, the basket at the very beginning is not removed. So you can see that we're just filling out a bar at the bottom. And that is because we're not actually drawing a background. Currently, even though it looks like it has a background, the background is just a black color and there's actually nothing behind this rectangle. So every time we move it, we just see the background as well. So what you want to do is right before you draw your basket, you want to draw in your background. So to do that, you simply just screen dot fill and you fill in with your background color. And now when we start, you can see the background is slightly gray bluish. And when we move, the background overrides the previous position that our paddle was at or our basket was at. And we can move left and we can move right. If I hold down left, I keep moving left. If I hold down right, I keep moving right. And the motion is pretty smooth. The problem right here is that if I go off the screen, I can simply just exit the screen and keep on moving. So I don't want my player to do that. I want my player to be at the maximum at the right of the screen or at the maximum left of my screen. So to do that, you simply just check. To check right here, if not game over, so every time it is not game over, I'm going to check if basket.x is less than 0. That means our player has gone too far to the left. If that happens, I just want to reset my basket x to 0. I don't want them to go further left. And if I try that right now, even though I'm pressing left key, my player won't go further left because every time it tries to decrease its x value, it's just going to be set to 0. Next, I have to check the right side. The right side is a little bit trickier because the width gets added to the right. So if basket.x is greater than width minus basket.width. So I have to account for the basket width as well. Because on the left side, actually, I have to pass this statement. So on the left side, this is where our x coordinate lives. So we can easily check if this is 0. If this is 0, it's going to be right here. But the rightmost portion has this whole width added. So you have to account for that added width by doing width minus basket width. If this is the case, we are too far to the right. So I'm going to set my basket.x equals to width minus basket.width. As simple as that. So now if I go too far to the right, I'll just stick right there. If I go too far to the left, I stick right there. And my player cannot move out of bounds. Our player movement is completely done. So after our player is done, we actually want the fruits to now fall. Currently, our fruits are not even being drawn on the screen. So let's draw our fruits first. So pygame.draw.rect. I'm going to draw on the screen. I'm going to use the color red, and I want to draw in my fruit. Let's see. Our fruit has been drawn right here. If I close and rerun this, it should be at a different position. So you can see every time we run the game, the fruit spawns at a different position, but right now it's just sitting there. We want our fruit to fall down, right? So inside if not game over, what I want to do is I want to move my fruit down. So to move my fruit down, I'm going to do fruit.y plus equals to fruit speed. Simple as that. Now if I start the game, my fruit starts falling down and it keeps on falling. So if I restart the game, it is going to fall down from a different position. And if I restart the game, it's going to fall down from a different position. But right now, even if you interact with the fruit just goes right through our player and goes to the bottom of our screen. We want the fruit to be able to collide with the player. And if it's colliding with the player, then the fruit should disappear, and our score should get increased. So if basket, which is our player, and we're going to check collide rect. So we're going to check if it's colliding with another rectangle, and that other rectangle is fruit. So if our basket was colliding with fruit, checking collision of basket with fruit. If our basket is colliding with our fruit, then score plus equals to 1. We're going to increase the score by 1. Then fruit.x equals to random.randint 0 to width minus 20. So this fruit is going to instantly teleport at the top of my screen at a random position again. So let's play it. So if I move left, it's going to spawn in at a random position, but it didn't go to the top. That's because I didn't do fruit.y equals to 0. So now every time it touches the player, it touches it and it goes to a random position at the top of the screen. So our base game feels kind of done. But if it doesn't touch the player, then it just disappears. It doesn't go to the top of the screen. So we have to check if fruit.y is greater than our height. So the y of our fruit is greater than our height. That means the fruit has gone off the screen without touching our player. Then all we want to do is we want to decrease the lives by 1 because the player has failed to catch that fruit, and we have to decrease the lives. Then we do the same thing. We reset the position of the fruit. So let's start it up. And if it collides with our player, then it goes to the top. And if it collides with the bottom, it also goes to the top. It works perfectly fine. And our score should also be updating live. So let's actually print out our score too. So let's print our score and let's print our score and print our lives. So let's play. And in the terminal, you should see your score now. So we touch it once, we got a score of 1. We got a score right here. We got a score of 2. We got a score of 3. We got a score of 4. And if you let it go, then we get a number, 4 and 2. We get 4 and 1. We get 4 and 0. So that was our lives. So 1, 2, 3, 4 was our score. Then we got 4 and 2, which was our score and lives. So our lives was 2. It decreased by 1 because we didn't catch it. Then it decreased by 1 again. We didn't catch it. And our lives went to 0. All right. Now, you don't actually need this. You can just remove it for now. So right here, if our lives is less than 0, so lives minus equals to 1, and if our lives has finished, so if we've gone through all of our lives, then we want to end the game, right? So if lives is equals to 0, then what we want to do is we want to set game over to true. Notice that we use the game over to true. Even if we do game over equals to true, our main window doesn't exist because our window is running on this running variable. If you set running to false immediately, so if we set running to false instead of setting game over to true, then our entire window would just disappear every time we ran out of lives, which is not fun at all. So we're just going to set game over equals to true, and I'm going to check if score is greater than high score. If our current score is greater than high score, then high score is going to be our score. And I'm going to save high score as high score. So if our current score that the player has is greater than the high score that we have stored, then our new high score is our current player's score, and I'm going to save it using the function that we created earlier. Now, if I go into my high score, there's currently 18 right here. Let's set it to 0. So I'm going to start my game, and I'm going to get a bunch of scores. So I got 1, 2, 3, and let's say 4, and let the game keep on going. So let me run out of lives real quick, and when I run out of lives, my game has been game over. Notice that when it's game over, the fruit isn't moving, and I cannot move my paddle anymore either, because for my fruit to be moving and for my paddle to be moving, it has to be not game over. So as soon as it's game over, I cannot move anymore. But the fun thing is that inside our high score txt, we can see that this text updated to be 4. Notice if we get a lower high score, so right now I got a score of 1, and I'm going to let the game make me lose. So I have 2 lives remaining, I have 1 life remaining, and I have 0 lives remaining, and we ended the game. I only got a score of 1. So if I got a score of 1, it doesn't get stored in here. This score is still 4. If I get anything higher than 4, then it'll be updated to show that score. Right now we're just printing it and guessing stuff, but soon we will put all of this on the screen so that it looks nice and playable. All right, our game is pretty much done. As you can see from functionality point of view, it is pretty much done. But the final thing that we need to change in this file is actually drawing stuff onto our screen. So our score, our high score, and the game over screen and everything, we need to draw it on here. Currently, we're just drawing the backgrounds, we're drawing our basket, and we're drawing our fruit. So what else do we need to draw? We need to draw if not game over. So finally, I want to do something. So if game over, if our game has ended, then I want to say that let's just print for now. Let's print game over, press space to restart. That's all I'm going to say, because on the top right here, the one of the first things that we did was the game reset event. If our game is over and we press space, then everything is going to be reset and we're going to set game over to false. So let's start up our game right here and let's purposefully go into a game over state. So I lost a life, I lost another life, and I lost my final life. So it says game over, press space to restart. And if I press space, my game has restarted again because we put that logic in. And the high score obviously gets stored every time we do game over. So we cannot actually see the score on our screen or see if it's game over or conditions like that. So we're finally going to draw in some text. So let's say draw in text. To do that, we use something called screen.blit. Screen.blit means we're blitting a text onto our screen. The first thing that we need to give is font. So we used our font on the top, font.render, and we're going to render the thing that we want to print. So I'm going to use an f string. So I want to print in my score as score. So I want to print in my score, and I want to set it to true. So setting it to true simply just, and I'm going to use the color white. After that, I'm going to give a tuple on the position where it's going to live. So let's say 1010. So I see a score on the top right here. This is the 1010 position. And every time I get something, my score increases and that gets updated at the very top. Pretty neat. Next, I want to draw in, let's say, my lives. So I'll simply just copy this. I'll simply just copy this down. And instead of score, I'll say lives. Instead of score, I'll say lives. And my destination, instead of 1010, let's say it's going to be my width minus 40 on the X and 10. That doesn't seem like it's enough. Let's say width minus 100 and then 10. Still a little bit off the screen. Let's give it 120. Okay, that looks much better. So I have 3 lives, I have 1 score. Now, if I lose a life, then it should update on the very top right there. Because we've put all the logic, we're simply just drawing it on the screen instead of printing out on the console. And if I let myself lose, so if I let all of my lives go away, then I'll have life 0 and it's going to print, press space to restart. If I press space, you can see that my score resets and so do my lives. And I still cannot move off the screen and everything else works perfectly. So far, so neat. It looks pretty neat so far. The other thing I want to print out on my screen is the high score actually. So the high score, I'm just going to say high score right here, high score. And it's actually, I want it to be on the middle of my screen, but I don't think that would be possible. So I'll just put it at the very left. So I'll put it at the very left, but a little bit down. So at 1050. So you can see my high score is right there. Now you can customize this so that it looks a little bit better. I don't think mine looks particularly good. I could maybe set this to something like 50 so that it's more towards the middle of the screen, maybe 100, maybe 120. So yeah, it's pretty much towards the center of the screen. I don't think that's a good position for it either. So you can set up a certain position wherever you want it. If you want to change the font sizes, you can use this font size right here. So mine is 40, you can put a different font size and then just test things out. Okay, so we have a high score, we have lives, and the last thing that we need is, instead of just printing out game over 1,000 times in your console, we want to show it on the screen. So I simply will copy this and I'll paste it and I'll just say game over, and I want to draw this not at 1050. I want to draw it at the middle of my screen, towards the middle of my screen. So I'm going to give it width divided by 2 minus 85. So minus the length of my text. And I'm going to do height divided by 2 minus 20. So around like the height of my text. So I'm going to simply just say game over right there. I'm going to copy this down and I'm going to say press space. I'm simply just going to copy that down, say press space, maybe tweak this values to minus 95 and minus 20 is fine. So let's start it and let's lose some lives. So as soon as I lose all of my lives, it says game over, press restart, but it overlapped. So let's put it on plus 20 right here. So it's going to fall over, it's going to fall over, it's going to fall over, and it's going to say game over, press space. Now, one thing I noticed, I don't know if you noticed this, but it was that my lives and high score have the same value. And every time I lose a life, I'm also losing a high score. And I think that is because I actually forgot to put in the high score variable. Yeah, actually it is. Instead of putting high score, I just put in lives. Okay, so my high score is 5. Let's try to get a new high score. So 1, 2, 3, 4, 5. Okay, I'm at high score and I got 6. So I got a new high score. So now if I lose the game or if I lose all of my lives, then the high score should update. High score is now 6. And if I restart the game, the high score is 6. Even if I restart the game from fresh, my high score will still be 6. The other thing that I noticed was that the game is pretty boring. It's because the blocks always fall at the same speed and it doesn't actually gradually get, more difficult. So one way we can fix that is we had a variable right here and the variable's name was fruit speed. So we can check right here. So every time we're colliding with the fruit, let's see where we're colliding with the fruit. So this is where we're colliding with the fruit and we're increasing our score by 1. Let's say every time we reach an even number. So if score %2 equals to 0. So this is trying to say every time we divide score by 2 and the quotient is 0. So that means every time the score is even, I want to increase my speed. So fruit speed plus equals to 1, let's say. And let's start this game. So currently my score is 0. My score is 1, so it won't increase. My score is 2, so it's slightly increased. My score is 4, so next time the blocks fall down faster. At 6, they fall down even faster. At 8, as you can see, every time I hit an even score, my fruit starts falling down faster and even faster. So it's going to reach a point where I can't actually keep up with my pal and I'm going to go to a game over screen. So that was it for this Catch the Fruit game. What you can add next, you can watch the future sections of this video and you can add some sound effects, you can add some sprites and make it look nice. This will be like a homework task for you. The code for all of this will be in the description. It'll be in our GitHub project. I'm looking forward to that. Pygame is a Python library for building games. It handles your window, your graphics, your input, your sound, and everything you need to go from a blank file to something that you can play. And it is simpler than you think. In this video, we're building a platformer from scratch. No prior game development experience needed. Just basic Python. Okay, so the first thing that we're going to do is we're going to set up our IDE to work with Pygame. Now you can set up your IDE in IntelliJ using PyCharm, or you can use VS Code. It'll be exactly the same. What I want you to do right now is create a brand new project folder. So IntelliJ, just create a new project right here, an empty project. And if you're on VS Code, just open up any random folder and then name it Pygame, whatever you want. Then I want you to open up your terminal. Now, opening up your terminal should be the same for even if you're in IntelliJ or VS Code. Just open up your terminal and type in some code. Currently, the first thing I want you to check is Python -- version, which checks your current Python version. Now, if you're running a Python version that's greater than 3.13, which is more likely, Pygame off the bat won't work for you because Pygame relies on libraries that work in Python version 3.13 and they don't really work on the latest version. So an alternative for that is we're simply just going to install pip install Pygame -CE. Now this C stands for Community Edition and it's a much more latest version of Pygame with more support, bug fixes, and core optimizations. And after you've installed Pygame CE, everything else should work off the bat. If you're running a version of Python that's older than 3.14, so 3.13 or 3.12, then you can directly just work with Pygame itself. Okay, before we get started, I want to talk through how Pygame works at a conceptual level. I'm going to do this by typing a concept file. So I'll create a new file and I'll just name it concepts. And in this file, I'll be showing you how Pygame actually works. So this is the fundamentals of Pygame. The first thing that you need to understand is the game loop itself. Game loop. So every game runs in a continuous loop where thousands of times per second usually. So every piece of code or every code that is inside the main game loop is going to run thousands of times continuously. And every one of these loop iterations is called a frame. And you've noticed if you play games, you have something called frame rate. And usually you either have 60, 144, 180, 200, like a standard frame rate that comes with VSync. If you're familiar with gaming, then you'll know these terms. So we want to control how many frames per second is being updated on the screen as well. Because if you have too high of a frame rate, you don't want your game to run faster. This would make it so that games would work differently on older systems and newer systems. So this is something that we fix in code itself. So each frame does three things in order. So each frame has to follow these three things. The first thing is process input. So anything like your keyboard, like your mouse, or like quit events if you're pressing the cross button on the screen or anything. So that's your process input. Each frame has to process these. Second, it has to update state. Now, state is a special keyword. State is anything, any object on your screen has a state. State is basically a property that something has. Now, it might be moving the player. So you're changing the player state. You're checking for collisions, which is also a collision state, etc. So you do all of these things inside the game loop. The third thing is you draw to screen. Well, after you check for collision or after you check that a player is pressing left or a player is pressing right, you actually have to update something on the screen. So you might have to clear the screen. You might have to draw the player again. So draw the player in a new location. You might have to flip the display or something like that. Like if you end the game, if it's game over, then you have to clear the screen and then show the game over screen. So that's drawing to the screen. So in each frame of the game loop, you need to do these three things. And we'll do this in order, highly in order. So all of these things happen. They start the moment game starts and they end when you quit the game. So from the beginning to the very end, this game loop is going to run multiple times every second, constantly checking for these three things. So that is the core idea of how games are made. Every single game that you've ever played, from either Pac-Man, Minecraft, Valorant, everything runs like this. It's basically a loop. Modern games target 60 frames a second. We will also target 60 frames, so this game is only going to be running at 60 frames per second. And these three checks or these three steps, they never change. So I'm going to first of all start by creating like a bare skeleton of a Pygame, how it looks like. The first thing you do obviously is import the module. So you import Pygame at the very top and you need to initialize it. So you simply just Pygame init. Then Pygame gives you a bunch of things that you can work with. And one of those main things that we constantly work with is the screen itself. It is the window that pops up when you initialize Pygame. So you can control this by giving it a variable, screen equals to pygame.display. And you can set the mode. So if you just want to display, that's fine. I want to set the mode, and set mode basically is a fancy term for saying the size of the screen. So it takes a tuple. I'm sure you're familiar with this data set. It's a tuple and it takes 800 by 600 is what I want my screen to be right now. The next thing that we're going to do is actually limit this frames per second. So every second, I want my game to be running at a constant frame rate, and that is controlled by a clock. So we create a clock, pygame.time.clock, and we can use this clock to limit how many times our game loop is going to run every single second. So by default, our game loop is running true. So our game should be running, and we start a forever loop. I mean, infinite loop somewhat, because currently running is true. So as long as it is true, this loop is going to run. So this is actually our main game loop. That's all. We're using the clock to cap the frame rate. So you can call it VSync as well. VSync caps the frame rate to your refresh rate, but we're just capping the frame rate to 60 in our case. So number one, Events. We talked about events, right? And number one, processing input. So those are events. So what you want to do is for event in pygame.event.get. So Pygame has a library of events that it stores inside pygame.event.get. So it might be mouse up, mouse down, everything is stored in here. And you can look at that event, so you can loop through each one of those events and check it. So if event.type equals to pygame.quit. So pygame.quit is an event. It is an event in here. And since we're looping through all of those events, if our event type matches the quit event, so that means if the player has clicked on the quit, we're checking it constantly, we simply just set running equals to pause. Pretty simple, right? Since when running was true, this main game loop would be running. Once we set running to false, we immediately exit out of our main game loop. So it just ends our game. So the second thing that we do is update. Currently, we're not really updating anything, so we'll just leave it empty for now. Empty for now, since we're not really updating anything. The third thing is we draw on the screen. So we want to, first of all, run events, then we want to update, and then we want to draw on the screen. So you can do a bunch of things to draw stuff on the screen. For now, let's just screen.fill, and I want to fill it with a color. So this would just correspond to a dark gray background. So notice that this should be 30, and it gives me a spelling error. So notice that this is also a tuple. So most of the things that you don't want to change, you input it in tuple. And then we want to do pygame.display.flip. So basically just pushing things onto the screen. So push to the screen. And finally, clock.tick 60. So it's going to wait 60. So every single second, it's going to make sure that this loop runs only 60 times. So this caps at 60 FPS. If you want higher frame rate, then you can change this accordingly. And we're going to run our file. So simply to run our file, you can either hit run on the top, but I won't do that. I'll go in here so that my VS Code fellows can follow along. And I'm simply just going to type py and then the name of the file. So concepts.py, and I'm going to press enter. And we see our Pygame window. See, we're almost there yet. We have a background, which is green color. We haven't changed the title or anything, but one thing that we did add was if we press the quit button, then this piece of code should run. So if you press the quit button, it says running to false, and that exits. You'll notice that if I comment this out and then run the file, that this quit button doesn't actually work. Your game is actually frozen, and this window is frozen. So you actually have to manually end this by exiting it here. So make sure that you add this to your code so that you're looking for that event, which is the cross button. All right, now let's dial it back. I'll continue in the concepts itself, but one by one, we'll be going through every building block that makes Pygame Pygame. So we have our main game loop here. I'll explain this one more time before moving on. We imported our Pygame, then we initialized our Pygame module. Then we set our screen. You can do a bunch of things with the screen, like resize it, set it to full screen and stuff that we'll look at. So at the very beginning, we just did pygame.display, and set mode basically just takes a tuple. Tuple is immutable data. And this is the size of your screen. So 800 by 600 pixels, width and height. Then we make a clock. So we use a clock to limit our frame rate. Frame rate means how many times we want our main game loop to run every second. By default, our game is running. Whenever we want to exit our game, so whenever we want to close the window, we set it to false. Now, this is our main game loop. So as we discussed before, our main game loop has to do three things. One, it has to process input, it has to update the state of our objects on our screen, and it has to draw those things to the screen. So in our main game loop, the first thing that it's doing is it's checking for something. So it's checking through every event. So pygame.event.get will give us a list of events that Pygame has. So it might be moving your mouse, pressing a key, whatever, every time. You'll use the syntax every time, so you'll get used to it. And we're pulling that into a variable called event. We're checking if that event type equals to pygame.quit. So pygame.quit is an event where you either do Alt F4 or press the cross button or exit from your window or anything like that. It detects it and calls it pygame.quit. So if you've done either of those things, then it's going to set this running variable to false. When it does that, this while condition becomes false and we exit our loop. The second thing we're doing in our loop is updating. Right now we have nothing on the screen to update, so we just left it empty. And the third thing is we're drawing on the screen. For now, we're just filling the screen with a dark gray background. We have to do pygame.display.flip to update our changes. So we're pushing our updates to the screen. And clock.tick60 basically means it's limiting this game loop from running too many times every second. It's going to make sure that it runs only 60 times every second and not more than that. Okay, now let's move on to PyGameRect. So PyGameRect is something that you'll be using constantly throughout this video. So it's basically drawing a rectangle on that screen. Simple as that. So everything on your screen is a rectangle. So the player that you saw at the beginning is also just a rectangle. So you can call it playerRect, which is your player rectangle, and call this method called pygame.rect. This will draw a rectangle on your screen. Will not draw, but it defines a rectangle that you can draw on your screen. We can first of all set the width, then we can set the height. We can first of all set the x coordinate. We can set the y coordinate, and we can set the width, and we can set the height. So if you hover over this method, you can also see that it is a rect class, and it takes in an x coordinate, a y coordinate, a width, and a height. After that, we can pygame.draw.rect. So we can draw this rectangle onto the screen by using pygame.draw.rect. The first thing that you have to pass in is where to draw it. You see, we took our screen at the very top, so we want to draw it on the screen. And we want to give in another position. So we want to pass in another argument, and this argument is simply the color. So I'll give it 0, 200, 0. So this is basically a color. And the last, this is RGB value, by the way. And the last is the rectangle that you actually want to draw. So player rect. And if you run this program now, so you can either press run on the top, but I'll just be doing py and then running concepts.py. Okay, so having known all of this, let's move on to more fun stuff. What makes your game a game? Well, you have components inside your game, right? Like your player, your platform, and everything. What do you think they're made out of? They're shapes. They're rectangles, and on top of the rectangles, we just put images. So the first thing that you need to understand is creating shapes in Pygame. So you can draw a bunch of shapes, more like drawing shapes. You can do this via a couple of methods. The first thing that we're going to be looking at is how to draw rectangles. Primarily, your entire game runs on rectangles. Your character is a rectangle, the platforms are a rectangle. Believe it or not, your enemies, your coins, everything are just pieces of rectangle, and you put images on top. So the primary function that we use to draw a rectangle is pygame.rect. And this method takes 3 arguments, what we call it. Arguments are basically things that you pass on to that method. So first you have your surface, then you have your color, and you have the actual rectangle itself. So let's start by defining what surface means. Surface is where to draw this rectangle. So usually you just have your screen and you'll draw this rectangle onto your screen. So your surface is just your screen. Second, you have your color. So color is the color of that rectangle. So what color you want it to be. This takes a RGB tuple. So tuple basically means non-changeable data value. So made of 3 numbers. So you can set a rectangle to be red by doing 255, 0, 0. So this would create a red color. because first is red, then you have green, then you have blue. So RGB. Next, after color, we have the actual rect. So rect is the actual rectangle that you want to draw on the screen. And we can create a rectangle using pygame.rect, and you have to define x, y, a width, and a height of that rectangle. Now, this might be all a bit too much when starting out, but we will go through step by step how to create a rectangle. All right. First thing you need to do is define your rectangle. So for example, I have a player rect. So a player rectangle, my player. Then I can create that rectangle using pygame.rect, like I defined right here. And I need a x, a y, a width could be something like 32, and height could be 48. So you have to understand what this x and y means. If you look at our game screen right here, on the very top left, the value of x and value of y are 0 and 0. As you move right, the value of your x starts to increase. As you move down, the value of your y starts to increase. So you must understand this Cartesian plane or this coordinate system. Generally, your normal understanding would be that y decreases when you go down, but in Pygame, it's the opposite. Y increases as you go down. So top left, you have 0, 0, x is 0, y is 0. If you want to move something to the right, you increase its x. If you want to move something down, you increase its y. Consequently, you can understand that the bottom right will have the highest value of x and the highest value of y. Also, when you draw rectangles, we look at the top left corner of the rectangle, and we'll see what that means right now. So on x 100 and y 200, so I want to go right by 100, and then I want to go down by 200. Then I want to draw a rectangle with the width of 32 and the height of 48. Now this just defines the rectangle. This defines the rectangle. It does not have a color yet. It doesn't know that it has to be drawn. We're not drawing it or doing anything to it yet. Where do you think we actually draw this rectangle? Yes, we draw it inside our main game loop. You see, inside the game loop, the first thing that we do is process input, we update state, and we draw to the screen. So this rectangle that we defined right here, so we define the rectangle here, but drawing it to the screen is actually the job of the game loop. So inside game loop where we're drawing to the screen, so we're filling the screen with a dark gray background and display.flip and clock.tick. So where do you think we would draw? We'll draw right after drawing our background. So first the background loads in, then our rectangle loads in. If we load our rectangle before we load our background, we can't see the rectangle, right? Because we draw the rectangle first and then we draw background on top of it. It's like painting a square and then painting a black color on top of the square. You can't see the square. So our whatever you want on top should go last. And to draw it, we know that we can use this function right here to draw it. The surface that we need is our screen on top. So this is our screen that we want. The color, so let's just say I want it to be green, so 0, 255, 0. And the rectangle that you want to draw is player rect. So right here, player underscore rect. And if you run this now, you'll see a green rectangle with the width of 32 and height of 48. You can see that it has moved right by 100 pixels, and then it moved down by 200 pixels. So it's more down than it is right, which makes sense. And where does this 100, 200 actually lie? So you can see the top left part of your rectangle, that is 100, 200. So whenever we move this rectangle, we're moving the top left portion of this rectangle, and we're just moving that around, and the rest of the rectangle is drawn from that point. So if I move it down by 300, this top portion is going to move down by 100 pixels. So just this top portion is going to move down by 100, and then we're going to draw the rest of the rectangle there. So you can see that it moves slightly more down. And if I want to move it slightly more right, then I'll change the value of x, so it goes a bit to the right. And this is basically our player. currently is just a box of green color, but we'll swap this green color with a sprite. A sprite is basically an image, and it will look like our player. All right, before we move on with our coding, I want a small section just to show you what assets we need. Right now, we're just drawing rectangles on the screen, but I want real sprites, real tiles, background music, and everything like that. So I'll just quickly show you where you can get all of these yourself. The ones that I am using will be linked in the source code. So if you go to GitHub, you can see a folder with all of the assets in it. But if you want custom assets for yourself, then these are a few websites that you can check out. So the first thing that you want to check out is itch.io. In itch.io, I want to search for Kenny Platformer Redux. So you can see Kenny Platformer. And if you scroll down a bit, you can see assets for Kenny Platformer. And there's a bunch of assets. So you can see there's ground, there's tiles for sky, health, and everything like this. So you can download it by simply just clicking download now. And if it asks you for a donation, well, if you want to donate, then you can donate. But otherwise, you can just click on no thanks, take me to the downloads, and you can download this pack from right here. So Kenny, I want to shout out, is one of the most prolific free game asset creator on the internet. So it creates a lot of assets that people can use, and everything is CC0, so public domain, no attribution is required, it's completely free of cost, but you can give a little kickback and donate to him if you like his work. So simply download this one. While that downloads, so you can go to opengamerart.org. This is another website that I use. And in this website, we can get some background music. This is one of the main archives. So Open Gamer Art. This is one of the main archives that people go to for game music. And you can just search for any like platformer tune, or you can look at 8-bit jump sound and stuff like that. So all of the assets that I use will be given to you, but if you want custom sounds, so you can look at the SFX. So there's multiple sound effects and everything that you can get from this website. Okay, in this section, I just quickly want to show you how I set up my project. So you can ignore these two folders, .idn, .pe, and v. These are just folders created by IntelliJ. So what I want you to focus on is not even this concepts file, but this assets folder. So I basically create a folder called assets inside my root folder. And inside it, I have 3 other folders. So I created these. First folder is images. And inside images, I have a folder called tiles. And inside tiles, I just have all of my tiles, so like my grass blocks and everything. And I have a characters folder where I have my characters and everything. All right. So if you want to do this yourself, I basically just extracted that Kenny assets folder, and I just made it so that it works like this. And inside music, all I got was an arcade level 8-bit music. Also, make sure that you're contributing your artist. So I got it from an artist called Wyvern9. So he made this music, and I just extracted it. So it's just a background music that I have for my game. And then in sounds, I have a coin sound, so coin collected sound. And I have a jump sound. So these don't have contributing artists, but I got them both from the second link that I showed you in the previous section. Now, if you don't want to set it up by yourself or download these assets, again, one more time, these will be in the GitHub. So you can simply just clone this folder and then get this assets folder, and everything will be set up for you exactly how it is and how I'll be doing it throughout this video. So now we'll get started with our actual game. So our game is going to live inside our main file. So main.py is going to be our file, and it is in the root folder. So to get started with our game, first of all, we're going to start with our basic structure. So we're going to import our Pygame. After importing our Pygame, we're going to do pygame.init, and we'll have our screen, which is pygame.display.setMode with 800, comma 600. So it'll just flash briefly and it will go away because we don't have a game loop right now, but we can see that we do have a screen. Let's also set pygame.display.setCaption. So let's set the caption to be our platformer game. And that's all we'll do for now. So the first thing, I want to display my player, right? So to display our player, generally, before what we did was we created a rectangle and we gave it a color and then called it our player and called it a day. But right now, we're going to use pygame.rect properly. And we actually want to draw the player that we got from our assets. So we have to load our player first. So we have to load the image. And the way we do that is pygame.image.load. So we're loading the image that we got earlier that we downloaded. And at the end, we have to do something called convert alpha. Now, I won't go into details what convert alpha does, but basically it makes it so that your images load properly, your sprites load properly, and the background PNG and everything, it just converts it into the right format that Pygame can use. So make sure that you don't forget this. It'll work without it too, but it might be a bit glitchy, a bit slow. So in this line, all we're doing is we're loading in our player. We're loading in our player sprite. Sprite and image are basically the same thing. I'll use those words interchangeably. So I actually want to go to my folder right here and assets, images, and inside characters, let's look at this. So I want to load this image. So I simply write in the path for that image. So I'm going to start with assets slash inside images slash tiles slash characters. So I have a folder called characters, and I want to get the tile 0000.png. So getting this path might be different for you if you're using different assets, but it should be pretty simple since all of your images should be inside assets and images. And inside this, it's pretty easy for you to figure it out, even though like VS Code and IntelliJ will give you the prompt like it did for me. It'll just auto-complete that for you. So we're basically giving in our image path and we're loading it in. So now if we use player image, we can access that image. Second, the image might be of different sizes and we actually don't know how big it is. The width, right now it's 24 by 24. Okay, we can see that, but we want to have a certain size inside our game, right? So we can resize that image. So I want to do that. So player image equals to pygame.transform. We're going to use .transform.scale. So we're changing the size of that image. So we're changing the size of player image that we loaded in right here. So player image, and let's change it to 40 by 60 pixels so that we know how big it is. So it's like 40 wide and 60 height so that we can use it inside our game. And that is pretty simple. So again, player image loads a PNG file from our disk and returns a surface. So this actually returns a surface. Our player image is a surface that we can draw on the screen. And remember that you're not forgetting this at the end, the convert alpha. So convert alpha is very important. It converts the image into a pixel format that Pygame can use. Then pygame.transform.scale resizes this image. So all of these assets that you use are used in various scales. We're resizing our image to be 40 pixels and 60 pixels tall, so that you can adjust these numbers to suit whatever game you're making. Okay, right below that, we have our player. So to actually draw the player on the screen, we have to create a rectangle like we did before. Let's say our player X, let's divide this. So at the very beginning, let's create our player rectangle. So player rect, like we did before, pygame.rect. And we can set an X coordinate and a Y coordinate. So we talked about coordinates before. And we can set a height, a width, and a height. So notice that the width and height that I used is same as the image's width and height, because basically on top of this image, we'll load this image. So on top of this rectangle, we'll load this image. So instead of the rectangle, we'll see this image. Notice how we're like hard coding this x coordinate and y coordinate, and we can't really change the rectangles x and y if we wanted to. So instead of passing in values directly like this, I'll just pass in player x and player y. Now these variables are defined, so I can define it here. Player x equals to 100 and player y equals to 400. So that every time we want to change the wherever this rectangle is, we can directly just change this variables and it will change where the rectangle is. That's pretty self-explanatory. Now to actually draw the player. So to draw the player, we do something called BLIT, blit. It is how you put a player onto the screen. So before that, we need our main game loop. So I'll just go ahead and go into my concepts folder, actually concepts file. I'll open this up and I actually just want to copy our game loop because I don't want to write it again. I'll come here and I will copy our game loop and I'll paste my game loop right here. I think we don't have the running variable, so running will be true by default, and we don't have our clock. So our screen, let's just write screen right here and let's add our clock. So we'll add our clock right on the top. And everything should be running. We don't want to draw anything right now, and background is fine, everything else is fine. So if we run it currently, we'll just see a black, more like a gray background with platformer game on top because we're not drawing anything inside the main game loop. Know that you have to draw something on the screen for it to show. But what we've done in this file is we've loaded our image, we've resized our image, and we created a rectangle. So currently our image and our rectangle aren't related, but we will bind them to each other in a bit. Let's start by drawing our rectangle and binding them with the image. So the way you do that is simply just screen.blit, so blit, and then you pass in your image first, so your image, player image, and then you pass in your rectangle, so player rect. What this does is you draw this surface, so player image is a surface, onto another surface. So player.rect, player underscore rect is another surface. Your first argument is what, and your second argument is where to draw. So since we use the top left corner, this is going to draw on the top left corner of 100 and 400. So let's run it. So you can see that our player actually appears on screen right here. And our player is like kind of stretched along the y-axis and in x-axis kind of squished together. So I can change this size value to make sure that it's perfect. So we had 25, 25 originally. So let's see how 25, 25 looks. So change the x, so change the player coordinate in the rectangle itself and change it in the image. And now when we run it, it's a bit small. So let's change it to 40, 40. Let's see how that looks like. And you can change these values around however you desire. So 40, 40, that looks pretty decent. So I think I'll be sticking to that size for now. And you can see that our player is loaded in. So actually this is just a rectangle. And instead of drawing the rectangle with a color, we just put an image on that rectangle. Okay, so far so good. I'll quickly explain through all of the code again. You can skip this part if you understood the code. We import Pygame, we initialize Pygame, we set our screen variable, and we set our title. Then we have a clock that maxes out our frame rate. Then we're simply loading our player into our game. Then we're setting the player's scale. So we're resizing the player to be a bit larger than it actually is. And then we have our physics variables. So velocity x is how much the player is going to move right every frame and how much the player is going to move left every frame. So if it is 1, that means every frame it is going to move right by 1 pixel. So in 1 second, since we're running it 60 frames per second, so every second it's going to move right by 60 pixels. Hopefully that makes sense. If that didn't make sense, then please Go back by 5 or 10 seconds and slow down that explanation and make sure you get it. For velocity y, we're going up or down. So if it is 1, then every second we go up by 60. So if it is 1, every second we go down by 60, since increasing value of y means we go down. If it is negative, then we go up by 60 every second. Speed equals to 5. So this is the value that we will use to change our velocity x. Since we increase the speed, our velocity x will be higher. If we decrease the speed, velocity x will be slower. Our jump force is -5, so we will apply this to our velocity y. So every second, if our jump force is -5, our player is moving up by 5 times 60. Gravity is 0.6, so gravity brings the velocity y higher. That means our player moves downwards. Since if the y increases, our player moves downwards. Finally, we have on-ground false. So by default, our player is mid-air until and unless we specify that our player is not. Then we have the actual player itself. So player X and player Y is the top left pixel of our player rectangle and where it spawns on the screen. Our player rect is a pygame.rect using that 100 and 400 right here and setting the width and height. Notice that our width and height is the same as the width and height of this image because we load this image onto the player. Then we have our main game loop. While running, we're checking every event. If there's an event that caused the game to quit, then we set running to false and our game quits. Keys equals to pygame.get.pressed, pygame.key.get_pressed. So we're checking to see every single key that is pressed every time. If we are pressing the left key, the left arrow, or we're pressing A, then velocity x is going to decrease by speed. So velocity x is now minus speed if we're pressing that key. If we're pressing right, then velocity x is plus speed. So velocity x is plus 5. So it's going to move to the right. Next, we're checking if we're pressing space, or we're pressing up arrow, or we're pressing double key. All of these mean that we want the player to jump. And our player has to be on the ground, since they should not be able to jump mid-air. If all of these conditions are met, then we can jump. We jump by setting the velocity y to jump force. Since our jump force is negative, then that makes our player rectangle move upwards. Next, we can apply gravity. So applying gravity basically means increasing the value of our velocity y by our gravity. Our gravity is 0.6, so velocity y is set to 0.6. Next is the actual moving part. Right now, we were just playing around with variables. These variables don't actually move our player rectangle yet. These two lines actually move our player rectangle. So the x coordinate of our player rectangle is going to increase by the x velocity x every single time, every single frame. So if velocity x is 0, then our player rectangle's x coordinate, so our player doesn't move in the x-axis. But we change the velocity x whenever we want the player to move left or right. We change the velocity y every time we want the player to move up and down. Next, we're checking bounds. So if the left side of our player rectangle, so we have left, top, bottom, and right. If the left side of our player rectangle is smaller than 0, that means we're going off the screen to the left. We want to prevent that from happening by just setting it to 0. If we're going too much to the right, then we're preventing that from setting it to the maximum allowed on the right. On the bottom, if we're going off the screen, then we basically set the max value to be right on the edge of the screen. And no longer should we be moving downwards. So velocity y should be 0 so that the player doesn't try to move further down. And we say on ground equals to true because we want the player to be able to jump from the bottom. And that in total results in a game that looks like this. So we can move left and we can move right. But you notice when I press left, I keep moving left. And when I press right, I keep moving right. Now we need to be able to fix that as well, since we want this to eventually decrease. And we can jump like so by pressing the up arrow, space key, or double key. If you want the player to jump higher, well, you can just increase this value. So set it to minus 15. And when we run this, our player will be able to jump way higher. And if you think the gravity is too less, then you can increase the value of gravity to something like 1.6, so that our player also jumps fast, falls down faster, jumps higher, and also falls down faster. So you can adjust these values based on how you want your game to feel. Okay, now that's out of the way. Right now in our game, our player isn't really looking at different directions. It just keeps looking left, even though when we press right, it's also looking left, and that's not really interactive. So all I want to do is, if our player is facing towards the right, then I want it to look to the right. And if it's facing towards left, I want it to look to the left. And that is pretty simple to do, actually. So above the game loop, right here, we can set a variable called facing right. And by default, let's set it to false, because let's run it. Our player seems to be facing left by default. So let's set it to false. Wherever your player is facing, just set it to that variable. And inside our input section, so right here, we can change that. Let's change it right over here. Let's say changing facing of player. If vel underscore x is smaller than 0, that means our player is actively moving towards left. If our player is moving towards left, then facing right equals to false. Simple as that. If vel x is greater than 0, that means our player is going towards the right, then facing right equals to true. It is as simple as that. Next, inside our draw section, we actually have to update that. So let's update it right after our screen blit. We're going to replace this line. So right now we're just drawing the player image facing left no matter what. But we want to replace this. So if facing right, so if the player is facing right, then screen.blit, player image, player rect. Else, if our player is facing left, then we want to flip this. So flipped equals to, we can flip this image using pygame dot transform dot flip. So we're basically just flipping the image. What do we want to flip? We want to flip the player image, and we want to set true, and we want to set false. So we want to flip in the x direction. So we want to flip it left and right. We don't want to flip it up and down. We don't want to make the sprite upside down. Right after doing that, we want to screen.blit, but instead of player image, we want to blit the flipped image. And that is all. If we play it right now, our player is looking to the right. When I press left, our player looks to the left. Actually, it seems like it is the opposite. So let's cut this and put it over here, and cut this and place it over here. So if facing right, then I want to flip, because by default I'm looking left. If I'm not facing right, that means I'm looking left. I just want to draw it as is. So by default, it is looking left. If I press the right arrow, it now looks to the right. You can see the eye of the player is looking towards the right. And if I press left, my player now looks left. You can see the eye of the player is looking left. Okay, so far we have our screen. We have our player, which is a rectangle with the image on top. And we did that by using this function called screen.blit, where we put the player image that we loaded onto our player rectangle. But this time around, I want to add gravity, and I want to add some basic player movement. So what you need to understand about gravity is there's something called a velocity. Velocity is speed and a direction defined. So speed is how fast we want our player to be moving, and direction is, well, where we want our player to be moving. If our player is moving downwards with a constant speed, that is gravity. right? If that doesn't make sense, then let's just look at it physically. So we have our physics variables. I want to define my physics here. So velocity in the x direction, so left or right. By default, we don't want to be moving anywhere, right? Unless the player has clicked on right or left key, we don't want the player to be moving anywhere. So by default, it is 0. Our velocity y is also 0 by default, so we don't want the player to be moving up or down either. Then we can set a speed variable to be 5. So every time the player presses right arrow, we want our x to increase by speed. So whatever speed, if we increase the value of speed, then x will move faster. If we decrease the value of speed, then x will move slower. And we'll implement that logic in a bit. Then you can set a jump force. So jump force is how high you want your player to jump. So this will be a negative value because on the y coordinate, if you want to go up, you have to reduce the value of y, right? So we're reducing it by a certain value to go upwards. So we're going to set it to 5 minus 5. Then we can set our gravity. So gravity, let's say it's 0.6. So we're going to add 0.6 to our velocity y to move it downwards. And every time we press jump, we want to add jump force to velocity y so that it moves upwards. And this will make sense. Last is we want a variable called on ground, and by default it is false. So since we don't want our player to be jumping in the mid-air, so we have to check if they're on ground, and only if they're on ground we want them to jump. So these are some basic physics variables that we use throughout any platform or game, and I'll comment these for you. So horizontal velocity, so player moving left or right. Then we have our vertical velocity, player moving up or down. So by default, they're not moving left, right, or up and down. So this is the speed at which player moves, speed at which player moves. This is the speed at which player jumps, so goes upwards. This is the speed at which player falls. And this is checking if player is on a platform. So if the player is mid-air or on a platform. Next, I want to add some keyboard inputs. So we do that where? We do it inside the game loop. So after events, we can create a variable called keys, and we can set it pygame.key.getPressed. So this is a variable that will hold whatever key we have pressed 60 times every second. So it's going to check for a key press 60 times every second since we use the clock down here. And the key that we're looking at is if keys pygame.k_left. So you'll be using this pattern a lot. So pygame.k_left basically means the left arrow. So if we're pressing left arrow, so all this line is saying if we're pressing left arrow, or keys pygame.k_a. So if we're pressing the left arrow or if you're pressing the A key on our keyboard, we want to do something. We want to set our velocity of our x. So we want to set the x velocity equals to minus speed. Since if we add speed to our x, the value of our x will increase and our player will go to the right. When we're pressing the left key, we want our x to decrease. So we're decreasing by the value of speed. So if we're pressing left arrow or we're pressing the A key, we want the value of our x to decrease by the value of our speed. Next, if keys pygame.k_right, I think you're seeing where I'm going with this, or keys pygame.d, k_d, that means that the player wants to go towards the right. So you have to increase the value of x. X equals to, or actually plus, equals to speed. Velocity is now speed. It has to increase by the value of speed. Next, if we're going to use a bracket here, keys pygame.k_space or keys pygame.k_up. So you can press space or you can press up or you can press even W, right? So, or keys pygame.k underscore W. So if you're pressing any of these keys, so if you're pressing up, space, or W, you want your player to jump. But there needs to be an and on ground. So your player needs to press either of these keys and they need to be on the ground to be able to jump. That makes sense. If all of that is true, then we want to change our vel y. We want to set it to jump force and we want to set on ground to false. Because now that we've jumped, we want to set our on ground value to be false. So let's go over these again. The first thing that we're doing is loading our player image. We're resizing our player image. Then we're creating a rectangle. Inside our game loop, we're drawing the rectangle on the screen with the image on top. Next, we're defining some physics variables. Vel x is the speed at which our player is moving left or right. Vel y is the speed at which our player is moving up or down. Speed is, well, the player of our speed. It is what we use to change these two variables. Jump force is how high our player jumps every second. And gravity is how fast our player is falling. On ground is checking if we're standing on a platform or not. Then inside our game loop, we're getting the keys. So we're checking what we're pressing 60 times every second. If we're pressing left or if we're pressing A, that means we want to move left, we set our vel x to minus speed. So at the speed, negative of the speed, because we want to decrease the value of our x. If we're pressing right or we're pressing D, then we want to increase our velocity, so we set it to the value of speed. If we're pressing space or up or W, that means we want our player to jump. And we have to be on the ground, so this prevents us from, jumping mid-air. We want to set our vel y to jump force, so this jump force variable right here. And we want to set on ground to false since we're mid-air now. Next, we want to actually apply the gravity. So we set the values, but those values don't really change our player's position right now. We want to change the player's position. So simply vel y by default, so we're applying gravity here. Applying gravity, vel y by default is going to increase with the value of gravity. So every second, the value of gravity gets added onto our velocity so that every second our player falls faster and faster if they're mid-air. Next, we're actually moving the player. So players underscore x. So player underscore x is this variable right here, which is our rectangle. If we increase this value, then our rectangle moves towards the right. We want to increase this value with our velocity. So vel x, player x is going to, actually we can use player rect.x, is going to increase with vel underscore x. This might be a bit confusing at first, but let's go through it. Our vel x is changed 2 times. So if we're pressing right, then our vel x is negative. If we're pressing left, then our vel x is negative. If we're pressing right, our vel x is positive. We're increasing the value of the rectangle that we're drawing on the screen with the value that is inside vel x. By default, it is 0, so our player doesn't move. But if we press left or right, it is negative or positive. So if it's negative, it moves the player to the left. If it's positive, it moves the player to the right. We do the same thing for our y-coordinate. So plus equals to vel y. The y-coordinate changes 2 times here. So either if we press jump, then the y-coordinate increases by jump force. And by default, it is decreasing by gravity. Is 0.6. Notice that the gravity is positive because the increasing y makes it go down. Another thing is we don't want our player to go outside our screen itself. So we have to check if the player is going outside the screen. If we run this currently, our player is just going to fall off the screen. So you have to make sure that it doesn't go out of the bounds of our screen itself. And that is pretty easy to check. We can check if player rect.left is smaller than 0. The player rect.left gets the left side of our player's rectangle. So the left side of our, we can stop the player from moving right now, and we can check. So this part is the left side of our player's rectangle, which has a coordinate, right? So we're checking if the left part is a certain value. So we can uncomment this and uncomment this. So if the player rect left is less than 0, that means if the player has gone too far to the left, then we want to set the player rect.left equals to 0. So every time our player tries going to the left, it's going to be stuck at the very edge of the screen and cannot go further than the edge of the screen. We have to do the same thing for right. So if player rect.right is greater than 800, notice that I used 800 this time because the width of our screen, as you notice on the very top, is 800. So the maximum value on the right is 800. If it's more than 800, well, I just want to reset it rect.right to 800. So the right portion of my player rectangle, if it's greater than 800, then I want to set it to 800 so that it cannot go further right. And the same thing for left so that it cannot go further left. Now, I don't want the player to go off the screen on the bottom either, so you can set this yourself. You can try it. Basically, player rect.bottom shouldn't exceed the bottom value. So our height is 600, it shouldn't exceed 600. How would you do that? You do it like this. If player rect.bottom is greater or equals to 600, then player rect.bottom should equals to now 600. And we can do something else too. We can set the velocity to be back to 0, so it doesn't try to keep on going to the bottom. And we can also set on ground equals true, so that we're telling the game that we're actually touching a floor. Now, if you play this, our player should fall, and it should fall to the very bottom. So it falls to the very bottom, and this condition activates. So when this condition activates, we see that the value is greater or equals to 600. It's trying to go further down. So we just set it to be exactly 600. So it's exactly touching the floor, and it's not trying to go down anymore, and on ground is true. When on ground is true, if you press W, space, or up, our player should go up, right? And it goes up by a little bit. It goes up by a little bit, but since we're constantly increasing by our gravity, it comes down eventually. So it goes up by -5, but every single frame, it is going down by 0.6. So eventually it cancels out. And we can go left, but we cannot go too much to the left because this condition activates. When we go too much to the left, it checks if the left is trying to exceed the 0, and it sets it exactly to that. And we can go to the right as well, but if we go too much to the right, it will stop us. So effectively, our player right now can go left, it can go right, and he can jump around, but they cannot go outside the bounds of our window. If we start the game right now, all our player does is it moves around, it hits a corner, and that's all it does. It really doesn't do anything. The first thing I want to fix is currently if I'm pressing left, then it keeps going left, and if I press right, it keeps going right. That's what I want to fix. I want it to eventually stop moving left or right. So in my applying gravity, what I can check is right here, if player, actually if vel underscore x is greater than 0, vel underscore x minus equals to speed. Let's see how that works out. That means if it's greater than 0, eventually it's going to decrease by the value of our speed. That works. I think it works. So, and we'll do the same if it is less than 0. If it is less than 0, then we'll plus equals to by speed. So that means our player can move left and right and they can jump. And if I keep holding it down, then it keeps getting added, because even though we're decreasing by speed, we're also increasing by much higher than that. So our player movement works for now. This is a bit janky, but it just works for now, and we'll leave it at that. The main idea of this portion is to create platforms for our player to be jumping in. Since currently our player is just jumping in, well, nothing, we need platforms for it to be able to jump in. And strap in, because this might be a little bit complicated. So first thing that you need to understand is we have a bunch of images, right? So we have tile 1, tile 2, tile 3. So the first tile is like the left part of our tile, and this is like the middle portion, and this is like the end portion. So if we mix these three, then we'll get, well, a block. First thing we need to do is actually load in those tiles. So right after loading in our player sprite, let's loading in our platform images. So we have 3 images. One is left, middle, and then right. So on the third one, the third one. So we have our left, and then we have our middle, and we have our right. Let's load our start. So let's name it platform start, and let's set it to pygame.image.load. Let's load the start image. So assets, images, tiles, tile 001.png, and we're going to convert alpha. Then we can do the same thing for 2, and instead of start, it can be platform middle. And the same thing for platform end, but instead of 2, we give 3. So we basically loaded these 3 images in. This image, and this image for our tiles. The next thing we're going to do is we're going to scale these. Currently, if we just draw them on the screen, I think they'll be a bit too small because it's 18 by 18 pixels. So let's scale these up a little bit. So platform start, I'm going to scale this by pygame.transform.scale. I'm going to scale platform start by about, let's set it to 32 by 32. Let's see how that looks. And I'm going to do the same for start, middle, and end. So start, middle, and end for our start, middle, and end. So it should be pretty simple so far. We're loading in our platform images, so 1, 2, and 3. And since they're 18 by 18 pixels, we're just resizing them to 32 by 32 pixels. So far, so good. Here comes the more complicated portion of the code, actually drawing these tiles in. So to draw these tiles in, we obviously have to go to the draw on screen section of our code. So when we're saying the player, if they're looking left, then turn left, and if they're looking turn right, right here we can draw these images. So to draw these images, we can simply just screen.blit. So we can screen.blit, let's say platform start, and let's draw it onto x0. So x0. Let's draw it onto y500. Let's draw it onto x0 and y500. Then we need to screen.blit after start our middle. All right, then we're drawing the middle. The middle is going to be 32 more pixels to the right, and this is going to be 64 pixels, the end. So I hope this all is making sense. It might be a little bit complicated, sure, at the beginning, but just follow along the code for now, and it should all fall in place. So if I start right here, I drew a small platform. Well, let's look at how this platform is loading in. All right, we'll go step by step in all of these, by the way, so that you don't get lost anywhere. I'm going to over-explain might even. And if you feel like I'm explaining a bit too much, then you can skip ahead. So first of all, we need the left portion, the middle portion, and the right portion. We loaded those in, and then we scaled them to 32 by 32 pixels. 32 by 32 pixels. Our player is 40 by 40, so you can see the player is slightly larger than these platforms. Next, we're going to actually draw these onto our screen. So where are we drawing it? Well, the first one, we're drawing it at x0, so that's why it's like stuck to the left, and y500. This at the very bottom is y600, and this is y500. So the top left is y500. And you can notice that the bottom left, so this would probably be y500 plus 32. So this is from 500 to 532. It makes sense, right? Because this sprite height is 32 pixels. Then we're going to start the middle. So the middle needs to be obviously a bit to the right. How much to the right? 32 to the right, because this image is 32 by 32. And if we move 32 to the right, then the top left will be x32. Then 32 more to the right, the top left will be x64. Hopefully this is making sense. Every single rectangle, when we position it by the top left. So top left right here would be 0, top left would be 32, top left would be 64. We can actually look at how this would look like. So if we did 32, if we did 64, and after 64 we did 128, you could see that there'll be one tile difference. So you can see there's a one tile difference. Since this top left is, this is a good exercise. This top left is 0, this top left is 64, this top left is 128. And since all of them have the same y value, which is 500, they're all on the same y axis, but on the x axis, they're like a bit left and right. So since our tiles are just 32 apart, we know that they should be 32 apart like this, and we can draw a platform. But drawing platform by hand seems a little bit, you would do this for a lot of times and then draw platforms and need to do all these math. So it's a bit complicated. That's why we use something called loops for this. So for this purpose, we'll be using loops. So basically what we defined right here was a tuple. So 0, 500, x, y, right? So we can define these up top and then we can use them right here. So to do that, first of all, I will create a list up here. Now this is going to get a little bit technical, so just please bear with me and follow along. It will be a little bit difficult to get at first, but I will explain it a bunch of times, so don't worry about it. So at the very top, after we load all of our platforms, I want to actually define where the platforms will live right on top. So I'm going to create a list called platforms. And on my game, for example, I want a platform on the bottom here. Maybe I want a few platforms on the top and everything. So I'm going to set those platforms by setting variables right here. So I'm going to set a bunch of tuples. So one platform, so the first platform that I want is on the bottom right here, from all the way to the left to all the way to the right. So I'm going to set 3 variables. First variable is going to be my starting position. I actually want to comment it out. So first is our start, then it is our end, and third is how many tiles. So we're going to start at x equals to 0. So I want to start at x equals to 0. I want to end at the very right. So that will be 600 minus 32, which is 544. Because since we take the top left of the rectangle, the very right, the tile that will be at the very right will have the top left value of the maximum width minus 32. I hope that makes sense. If it doesn't, just follow along. And the number of tiles will be, well, 600 divided by 32, which comes out to around 25. So this will be around 25 tiles. This is one tile. Next, I maybe want another platform. So I'll just draw out another platform. So maybe I want to start at x equals to 192 and end at 448. And I want 9 tiles in that gap. Then, for example, I want 384 and I want to end at 160 and I want 4 tiles in that gap. Now, all these values won't make sense to you right now, but I will make them make sense very shortly. So right here, instead of drawing our rectangles manually, we now loop. Now, this is the main portion that people get stuck on and some of you may quit. So please pay close attention to what I'm saying. We're going to loop through this list. We're going to loop through this list, get all of these values and draw our tiles out. So let me copy the format, right? Let me copy the format right here so that I can see what I'm working with. Let's copy it right here. And right above our loop, where we're going to loop, let's write it over here. and let's say looping over the platforms to draw. For we have three variables, start, end, and how many tiles. I'm going to set the start into a variable called x, and to be y, and length to be just length in platforms. So platforms is our variable, right? It is our main list. So for x, y, and length in platforms, so in the first iteration, we'll get 0, 5, 4, 4, and 25. Second time, we'll get 192, 448, and 9. Third time, we'll get 384, 160, and 4. Now, we could just draw them out randomly, but one special thing that we need to do is the first tile must be this, and the last tile must be this. Everything else, anything in the middle, should be this. So we have to check that condition. To check that condition, we need to loop again. So we need to create a second loop. So for I in range length. So length means how many tiles are there. If I equals to 0, that means if we are on the first tile, if we're drawing the first tile of that platform, then our tile is going to be platform start. We're going to use the start platform. So we're going to use this one if it is the first tile in that platform. Elif I equals to length minus 1. That means if this is the last tile, we're checking if it's the last tile. If it's the last tile, then we want to use this one, right? This one is stored inside tile equals to platform end. Anything else, so anything else means we're like in the middle. So if we're in the middle, we want to use the tile platform middle. Again, I'll explain this. For x, y, length, and platforms. So each one of these tuples, this is one platform, this is another platform, this is another platform, right? So we're looping through every platform. We get the first platform. Now that first platform has a number of tiles where it starts and where it ends. We're looping through the length. So we're looping through how many tiles there are. If we are on the first tile of that platform, we want to use the starting tile. If we are in the middle, if we're in the end, then we want to use the ending tile. Anything else, we want to use the middle tile. At the very end, we have to actually draw this. So to draw this, simply just screen dot blit. We're going to draw the tile. So we're going to draw this tile. And the position where we draw it needs to also automatically be appended in the loop. So we get the x. X is where we start, right? And we add I times 32. Since our width of every tile is 32, if it's the first tile, then I will be 0 and we'll just start at wherever x is. The second tile needs to be placed like 32 pixels to the right of the first tile, because actually this will give an error right now, but if you look at your screen, if you have your first tile here, your second tile should be placed 32 pixels to the right of that. So I times 32. Then we can get our y coordinate. Our y coordinate can just be y, because every platform will be on the same y plane. So we'll just use the y coordinate as is. If we run this program now, we can see that we got 3 different tiles. So for the first platform, let's look at it. We have our first platform. We start at 0. So we start on the top left, 0 right here. And we end at 544, which is right here. The number of tiles that we have in between are 25 tiles. That's this width, 600, divided by 32. And inside the loop itself, what we check is, so x, y, and length. So x, y, and length. Our y is around, let's see, our y is 544, so it's 544 down. And our x, so the first time our x will be 0. Next time we're going to add I times 32. So in the first time it'll be 0 plus 32, then it'll be 0 plus 36, 0 plus 64, 0 plus 128, 0 plus 256, and it goes on like that until we reach the end of the screen. And if we're drawing the first tile, so if I is 0, the first tile, we're using the first one. For everything else, we're using the middle one. And for the last tile, we're using the last block. And these are just 3 different platforms. Now you might be questioning, how we actually get these values. Well, one way is to manually do all the maths yourself and get these values. But for your ease, I've created a script. And this script will be available to you in the GitHub, and it's called Tile Editor. Basically, what this script does is it checks where you're clicking on and it gives you this tuple, so this list that you can work with. Simply just run this program and you'll get a grid like this and go on to click. So I can create a platform right here. Let's create a platform. If you want to unselect, just click it again. So I'll create a platform like this, like so. And maybe I want some tiles over here as well. And I want some tiles over here. Maybe some tiles here. And let's jump around. So let's jump around to here, maybe jump around to here, and create some tiles over here. So maybe I want to create a tile sheet that looks like this. So you create it, and then you click on close, and inside the console where it ran, it will give you the platforms you generated. So I made 1, 2, 3, 4, 5, 6, and 7 platforms. The first platform starts at 0, ends at 576, and it's 25 tiles long. The second platform starts here, ends here, it is this many tiles long, and so on and so forth. So I'll copy these, and inside my platforms, I'll just paste them in. I'll paste them in. So after this section, I'll add like a visual section where I'm explaining all of this by drawing it out. And you can look at that section and then make sure that you understand this portion of the video, because I know it can be a lot at the beginning and it can be a little bit complex, all the maths behind it and everything. If you're interested in learning it, then go ahead. If you're not, then all you need to understand is we're loading, we're scaling it, we have a list of platforms that you want to draw. Every tuple in this list represents one platform. It is the start, it is the end, and this is the number of tiles. And all this loop does is it goes through everything and draws it out on your screen. Just understand that much superficially. Now, if you start it, the thing that we drew earlier, we get it perfectly in our tile format. Simple as that. All right. So far we have our game where we can jump around and we're colliding with the edges and the bottom, and we've created some platforms, right? But you want to be able to jump around these platforms and not just, like go through the platforms. So you need to add platform collisions. The way you do that is quite simple, but the logic for it can be a little bit complicated. So right now, all our platforms are a bunch of variables or a bunch of tuples. So these tuples aren't actually rectangles yet. We need to convert them into rectangles to be able to use them to check if we're hitting the player. So around over here, after we're checking all of our key games, we're going to do a loop. So we're going to create a list, platform rex, and it's an empty list for now. Basically, what I want to do is I want to convert all of these just raw values. So right now, these are just raw values where we're placing images, right? So I want to take these raw values and I want to draw rectangles. And based on those rectangles, I want to check if my player rectangle and those rectangles are colliding. Since I don't want to hard code anything, I will just take these values, these tuples, and I will create rectangles using those. So the logic is pretty simple, platform rex. And again, we take for x, y, and length. So these are 3 things that I have in platforms. So again, platforms looks like this. I have x, y, and width. I'll take those 3 things and I'll create a rectangle. So rect equals to pygame.rect x, y, and length times 32, because the length right now we have like 25 tiles. So if you have 25 tiles, the length is going to be 25 times 32, because one of these tiles is 25 long. So if you have 25 tiles, actually one tile is 32 pixels long. So if you have 25 tiles, obviously it'll be 25 times 32 pixels long. So length is going to be 25 times 32, or whatever the length is. So if there's 7 tiles, then it's going to be 7 times 32 long. And the height is just going to be 32 because all of these rectangles, no matter how big the platform is, it's just 32, right? So we have, let's say, 25 tiles right here. So it's going to be 25 times 32. It's going to create a rectangle that is 25 times 32 long. And the width of all the rectangles are just going to be 32. And the starting and ending position is given right here. So we just use the starting and ending position right here. In the very end, for every rectangle that we create, platform rex.append rect. So now we have a list. What is in this list? Basically, every single rectangle that we're defining right here is now actually a rectangle that we can work with that exists in this list. So this is a list of all the platforms in rectangles. What this is doing is it's converting our platforms raw list into Pygame rectangles. Now we have rectangles, so we can actually check collision against those rectangles. Here is where I'd like to reorder a few things. Velocity should always be added at the very end. So the velocity variable that I have right here should be added at the very end. So I'm going to cut it and I will add it at the very end right here. Just make sure that this is at the very end because we'll be moving our player a bunch and velocity should be added at the very end of that. Next, we're going to look at rect X and rect Y. So looking at our player and these platforms, our player can collide with the platform two ways. Either the player collides with the bottom of the platform or the top of the platform, or the player collides with the left and the right of the platform. So we have 4 different collisions to check. At the very beginning, I want to check if the player is colliding to the left or the right of the platform. So for platform in platform rex, so we're getting all of the platforms that we have right now, and we're checking if player rect dot collide rect platform. So we're checking if the player is colliding with any platform that is currently on the map. So every single platform we have inside this list, and we're basically checking if our player is colliding with any of them. If our player is colliding with any of them, we're going to check a few more conditions. If the velocity of our player, vel x, is less than 0, so if the player is moving left while colliding with a rectangle, player rect.right equals to platform.left. So understand this line of code. This condition means that our player is moving towards the right. Our player is moving towards the right and it collided with a platform. So player rect.right, that means the right side of our player should equal to the left side of the platform. If this player is moving towards the right and it collides with this platform, that means the left side of this platform should equal to the right side of this player. So the player shouldn't be able to move further than the left side of this platform. And that is basically the platform collision. As you can see, I was colliding with this rectangle and it updates. So my player cannot move further right because the right side of the player is locked to the left side of the platform. It's a bit glitchy now, but it will make sense. The other condition is if the player was moving left. That means if the player's velocity is less than 0. Then the left side of the player, so the left side of the player should equal to the right side of the platform. Simple as that. If the player is moving right, then we should hit the left of the platform. If the player is moving left, then we should hit the right side of the platform. It is pretty simple. Just pay more attention to it and I'm sure you'll get it. Next, we want to check for the Y collision, so the top and bottom. So for platform in platform rex, so we're going to get all of the platforms and we're going to check if player rect.collide rect is colliding with a platform. So in both of these cases, we're checking if the player is colliding with a platform. In this case, we're checking specifically if it was colliding when moving left or right and set it so that we're not colliding inside the left or inside the right. In this case, we're going to be checking if it's colliding top or bottom. So if vel y is greater than 0, that means our player is currently falling. If our player is falling while colliding, then player rect.bottom equals to platform.top. So doing this basically means we were falling, right? That means our velocity y was greater than 0. We were falling down. When we're falling down, if the bottom of our player is colliding with the top of the platform, then we want to set the bottom to be equal to the top so that our player can no longer go through that platform. Also, right after doing this, you can see that it is glitching a little bit because it keeps trying to go under. To stop that from happening, we simply just set the value of velocity y to 0. That means the player will no longer fall. Once it has touched this platform, it will no longer try to go further down. So you can see it stops glitching. Also, right now, if you do this, our player cannot jump. I'm pressing space key right now, but I cannot jump. That is because our on ground, so this variable is false. We have to actually set it to true. On ground, set it to true. That means we're telling our game that we are currently on the ground and we should be able to jump. So now we should be able to jump right there. You can see that I cannot collide with the left of this because as soon as I collide with the left of the platform, the game checks if I'm colliding and it sets the right side to be equal to the left side. So it cannot go inside. Right. I also feel like this jump speed is a bit less. The jump force, so I'll increase it. Let's set it to something like 12 for now. Okay, I can jump a bit higher. And you can see that the left side is colliding. The left side is colliding. Let's try to collide on the right side. The right side, oops, the right side should also be colliding. The reason why we're glitching and going through platforms is because currently we don't have collisions for the bottom of the platform. So we can simply just, go clip through the bottom of the platform like this, which is really not ideal in a game because it leads to glitches like these where you can just clip through the bottom of the platforms and it moves left and right. So for that, we're going to check if we're colliding in the bottom. So if velocity is greater than 0, that means we're falling. Similarly, we can check if velocity is less than 0. If velocity is less than 0, that means we're currently jumping. So player rect.top equals to platform.bottom. So the top of the player should not exceed the bottom of the platform. And again, we'll set our velocity y to 0. We're not going to set on ground to true because just because the head of the player collided with the platform doesn't mean that we're standing on ground. So if you do that, now if we check this, we cannot go through the bottom. Our head collides with the bottom and we cannot no longer clip through these platforms anymore. And we've efficiently created a place where we can collide with platforms and we can move around. And of course, you can create your own custom platforms. So far in our game, if you run it, you can move around with your player pretty smooth. We might fix the player movement later. It's a bit janky because as soon as you leave it, the player stops moving mid-air. You might want to add some inertia where there's eventual decay. So like if I let go of A or W, it like gradually stops instead of instantly stopping. And our player moves pretty nice. Now there's only a few things we need to add. So like we need to add levels. In our level, we want enemies to be moving around, and then we want some coins. And if you collect enough coins, then you win the game. If you touch an enemy, then you lose the game. So in this section, let's start by adding enemies. So right after we load in our platform images, let's load in our enemy image. So we have a bunch of images for our enemies. Let me look through. I think around not tile 24, I think around tile 24 of characters. Okay, we have a bat. Let's try using this bat as our enemy. Right. So right after loading our platform images and everything like so, let's loading in our enemies. I hope all of this is making sense. We're going to load in our enemy with enemy img variable pygame.image.load. And I believe it was assets images, tiles, characters, and tile 24. Don't forget to convert alpha. And I want to resize this as we always do, pygame.transform.scale. Let's set it to enemy image and let's resize it to 40 by 40. Right, so far so good. Next, we have a list for our platforms. And similarly, I want to have a list for my enemies. So I'll have a list of enemies. Usually in your games or like in production games that we use Pygame in, you wouldn't do it like this. You would use object-oriented programming where you would create classes and instances of that object. But since I don't want to complicate you with all of that stuff, I'm doing it very simply, just using lists. But normally you would do this using objects. Okay, so enemies. Our enemy needs to have a few properties. So it needs to be a rectangle. It needs to be looking at a specific direction, and it needs to start at one point and end at one point. So for example, I want an enemy right here. It needs to start here and end here. So it just needs to move back and forth right here. I don't want it to move anywhere else. The enemy itself is a rectangle, and it might have a direction of movement, right? So if it's facing right, I can set its direction to 1. And if it's facing left, I can set its direction to -1 or something like that. So I want a single enemy to have multiple properties. So using a tuple wouldn't really make sense in this case. So I'll use a native Python type, which is a dictionary. So a dictionary can have multiple values. So let's set one enemy. Let's set the key rect to be just a pygame.rect. And we'll start it at 200. We will end it at 400. We'll set the x to 200 and we'll set the y to 400. Then we'll set its size to be 40, 40 because that's the size of our enemy image. Now, I'm sure you're familiar with dictionaries, but if you're not, basically understand it like a box. So it's a box where you can have multiple properties for every single thing that you create. Since we need our enemies to have multiple properties, like it needs to have a rectangle, facing direction, how far it's going to move. So I'm creating a dictionary. Speaking of that, right after rect, I'll set its direction. So let's set direction by default to be 1. So it's moving towards the right, maybe if it's 1. Then let's set a minimum x value. So the minimum value, the least amount to the left it can go. So let's set it to be around 100. And let's set a max x value. So max x value, let's set it to something like 300. So it's going to move about in 100 and 300. So it's going to start maybe at, so if it's 200, 400, so it's going to start around over here. And the minimum it's going to go is all the way to the left 100 right here. And the maximum is going to go to the right 300 right here. So it's going to move back and forth in this direction. And we've defined our enemy like so. Now we actually need to add the movement logic. Now the movement logic is always going to go inside the game loop itself. And we'll do this. So we can do this right at the top, right after we take all of our player inputs and right before our update section. So right before our update section, we can do something like enemy speed. So we want our enemy to have a speed, right? Like our player has a speed of 4, our enemy might need a speed 2. So for enemy in enemies, so we're pulling out that list and we're getting a dictionary. So when we do enemy, we get this. First of all, we get this one. And if we add a comma and then add in another enemy like so, like same, we can copy this and paste it. So we can add another enemy like so. Let's say instead of 200, 400, let's set it to 800 and 300. Let's set minimum x to be 700 and maximum x to be 900. Actually, 900 would go off the screen. So let's set this to be 700 instead, and let's set this to be 600, 800. Something like this. So the first time it'll pull out this enemy, and the second time it'll pull out this enemy. So every time we pull out an enemy, right here, every time we pull out an enemy, the first thing we need to do is enemy and get the rectangle. So rect will give us our pygame.rect, and which we can access the x value. So it gives us this pygame.rect and we can access its x value, right? So we need to check, we need to actually increase the X value by enemy speed times enemy direction. So if it's 1, then enemy speed is going to increase by 2. If the direction is negative, then our enemy speed is going to decrease by 2. Makes sense. Since we're multiplying by this variable, if it's positive, it'll go to the right. If it's negative, it'll go to the left. And after that, we need to check. So we need to check if we're out of bounds. So if enemy rect.x is, let's say, smaller than or equals to enemy minimum x. So we have a minimum x value, and if the rectangle has gone too far to the left, we want to reverse the direction, right? We want to reverse the direction. We actually want to set it to 1. So 1 means that now the enemy starts moving towards the right. This means if we go too far to the left, we want our enemy to start moving to the right. And we'll do the same thing, but this time, if rect x is greater than equals to the max value of x, so it's gone too far to the right, we want it to start moving left. Because since we're multiplying by this variable right here, we're multiplying it by this. When we multiply the speed by negative, our x will start going towards the left. And that should be it. If you play it right now, you won't see your enemy. And can you tell me why that's the case? Well, because we haven't drawn our enemy on the screen yet. We have to do that in the draw section. So right here, we're drawing our player. So this is drawing our player. Let's say this is drawing our background. Remember, anything that you put at the last will be drawn on the very top. So if you draw our enemy before we draw our background, our enemy will be hidden. So first we draw the enemy, then we draw the player on top, and then we're drawing the platform on top. And let's draw our enemy on top of everything else. So enemy drawing. All we need to do is for enemy in enemies, we take every single enemy in enemies and we draw it. So screen.blit. We want to draw the PNG, so enemy img on enemy rect. So blit means we're taking that image and then we're drawing it on top of this rectangle. And if we play this file currently, as you can see, we get 2 bats. So this bat is moving left, and as soon as it notices that it's going too far left, it reverses its direction. If it's going too far right, it reverses the direction, and same for this. So it stays inbound for both of those bats. This bat is going too far to the right, so I might want to change that. Maximum is 800, so let's just set maximum to be 700. Let's draw it at 600, and let's do 500 for this. So you can play around with these values to draw your bat where you would like. Also, you likely don't want it to collide with your rectangles like this. So just play around with your enemies and just set them where you would like them to be. And then we can move on. So minimum, instead of setting to 500, let's set it to 600 nay. And our enemy, okay, our bat is just moving left and right there. The next thing you want to do is you want to check if your player is colliding with the bat. If your player is colliding with a bat, then let's say you want to immediately over the game. So you just want to print out game over if you're colliding with a bat. And we'll do collisions in the next section. All right. So far, we can start our game. And I've changed up the sprites of the platforms and then the enemies a little bit. You can go into the level editor, so like the tile editor file that I've made, and then create your own level like this. So you can move around like this. And this is a pretty fun one. You can jump on all the platforms. Some are a bit tricky, so you have to dodge this bat a little bit if you want to get here. And you have to dodge this bat as well, so you have to perfectly time it. And moving between platforms is pretty fun. Right. Now, all we need is the first thing we need is when we touch these enemies, currently nothing's happening. What I want to do is as soon as you touch an enemy, the game is over. So like you don't want to touch any enemies throughout this game. And there'll be coins throughout that you have to collect all the coins. And once you do all of that, then game is over. And you win. So to do that, first of all, let's exit out of here. All I want to do is create a function or like create a functionality where if you touch an enemy, you stop playing the game. So like you cannot play the game anymore. So I'll create a variable called game state and let's set it to playing for now. So this is going to change playing, game over, or win, right? So three things. And we're going to check collision, basically just basic collision check. So right before I'm drawing the screen, I'm going to get for enemy in enemies. So I'm getting all of my enemies. And if player underscore rect dot collide rect enemy rect. So I think that's all I'm going to check because let's have a look at our enemies that I updated. So if you look at our enemies, then the enemy has a rectangle around it, and we can check for collision with this rectangle. We're basically saying if our player is colliding with our enemy, then I want to set the game state to game over. And that's all I'll do actually. And I will actually wrap this in another for if statement. So if game state equals to playing. So if the game isn't playing, then we don't need to check this at all. It'll automatically be game over, right? I think, okay, so it's playing. If we're not playing, it's going to be game over anyway, so we don't need to check this. Now, what does game state equal to game over actually do? Well, I don't want everything to stop. I just want the player to not be able to move anymore. So I can create a if condition here. If game state equals to running. So if game is running, then I want my controls to work. If game state equals to anything else than running, then none of these will work, so my controls won't work anymore. Let's check that. So I think I touched the bat as soon as I started. So if I move around, actually running, it's not running. I think it's playing, that's why. So if I move around, I can move around perfectly, but I hit a bat right there and now I cannot move around anymore. So I can move around as long as I don't hit a bat, I can move around. So I hit a bat right there and now it's game over. So for basics of game over, that's all I'll do for now, and we'll add an ending screen and sound and music in it. All right, so far we can move around, we can hit enemies, and as soon as we touch an enemy, it's game over. We cannot move around anymore. So the next thing we need to add is actually a score system where there are coins and you can collect the coins throughout the map. So inside our assets, let's look at images and let's look at if we have a coin looking like object. So we have keys, we have mushrooms, and okay, we do have gems. So tile 67 is a gem. Let's see if we can find anything else. Oh, we do have a coin. Okay, tile 0151 is a coin. So 0151 will be our coin. Let me just close everything else and go back to my main, tile 0151. So right after loading our enemies and loading our player platform and everything, let's load in our coin. So loading in our coin, which is coin img equals to pygame dot image dot load assets slash images slash tiles and then tile 0151. So 0151 dot converted to alpha. Then enemy, no, actually coin img, we need to resize it, pygame dot transform dot scale coin img, and let's set its size to be a bit smaller, so maybe just 32 by 32, and that's our coin. Next, similarly to how we created platforms and how we created enemies, we're going to create coins. So coins equals to, it's going to be a list, And inside this list, we're going to again create a dictionary. So the first value that we want in our dictionary is the rect, which is the rectangle that the coin is going to sit inside. So pygame.rect, and we can give in a few values. We can play around right here. So let me look at the platform. Let's place 1 at the start of every platform. So not every, but a few of the platforms. So let's go to x0, then y instead of 160, I'm going to reduce that by 32. So I'm going to place it at y 130. And it's going to be 24 by 24. And I'm going to set another property on it, which is collected. So if the coin isn't collected, then we don't want to display it. By default, collected will be false. Let's just set up 1 coin for now, and I'll do the rest in my free time, and you can follow along as well. Next, we actually need a global score. So instead of, I'll just add a score variable, and I'll set it to 0 by default. Now, we need to check for collisions against coins. So similarly, how we check for collisions against, well, everything, we can check collision against coins right here. So we're going to loop through for coin in coins, every item inside coins. And if not coin collected, so if true, coin collected, if it's false, then this condition will be true. So if our coin has not been collected yet and player rect is colliding with that coin, so player rect collider rect is colliding with our coin. So what we're checking right here is if our coin is not collected. And if our player's rectangle is colliding with our coin's rectangle, then we want to set the coins collected to true, first of all. So now that the coin is collected, this condition can never be ran again on the same coin, meaning one coin cannot be connected multiple times. And I want to increase my score by, let's say, 10. Lastly, I can have an if condition. So this is simply to collecting coin logic. And I can set another. So this would be win condition. Win condition can be if our score is greater than equals to the length of coins. Then game state, earlier we did game over, we can do game state win. Now length of coins times 10 should be in place because we're increasing our score by 10. If you just increase your score by 1, then you don't need this times 10. Okay, that's all it is. And now finally, we should be able to play our game and collect coins. But if you start up right now, again, you cannot see the coins because we haven't actually drawn the coins in. And we'll do that while drawing on the screen. So at the very end, after drawing our enemy, let's say coin drawing to draw our coins. And this is also pretty simple. So for coin in coins, if not coin collected, so we don't want to draw coins that already have been collected. Any coins that haven't been collected get split onto the screen. So we get the coin image and draw it on the coin rectangle. And all of our coins should be on the screen. Well, there's just one coin at the very top right there. Let's try to get to the coin without dying. So I'm going to come right here. And once we get the coin disappears and our player stops moving. Because after the coin disappears, the game condition becomes win and it's not playing, so our player cannot move anymore. Since we had just one coin, as soon as we collect a single coin, the game ends immediately. So we can add multiple coins. Let's just add another coin. Let's see here, where can I add another one? I can add another one at the edge of the screen, or I can add one at the bottom of the screen. Let's try to add one at the bottom. So instead of 130, let's see what the bottom platform would look like. Let's set it to 500. And okay, there's a coin right here. Now, if I just collect the coin at the top right here, our game shouldn't end. See, I can still move around, but as soon as I collect the last coin, the game ends and I cannot move around anymore. Well, we cannot really see our score right now, so I should add a way that you can see your score. So to add variables to your screen, so like to add text to your screen, the first thing that you need to do in Pygame is create a font. So font is basically a Pygame object, so pygame.font.font, and you set none and 26. So none basically means you use the default font and you're not using a font file, or you can add a font file if you want to use a custom font. And 26 is basically the size. So you're just creating a font. And in your draw section, right after drawing your coins, let's draw in our score. So we're going to set score text equals to font.render. So we're rendering using a font, and we're going to create an f string. So coins is the score that we have, divided by length. Let's divide it by the length of coins. That is our score. Let's set it to true. True means let's not look into that. And let's set a color. So color might be 255, 220, and 0. Again, an RGB color. And after we've defined our score text, let's split it onto our screen. So let's show it onto our screen. We're going to show score text, and we're going to show it at 10, 10. So we created a font at the very top. We defined a score text, and in our score text, we have this text. Then we have anti-alias true, and we have a color. Right after that, we split it onto the screen like so. So let's see how that looks like in our game. You can see we get coins 0 out of 2. Now, if I go ahead right over here and I collect this coin, I get coins 10 out of 2. That is a mistake because on the score on top right here, I'm multiplying it by 10, whereas I should just multiply it by 1. So I'll find where I'm multiplying by 10. So right here, I'm increasing the score by 10. So let's just increase the score by 1 instead of 10. And let's play that game again. And this time, I'll move around. I'll collect this coin, and now I get coins 1 out of 2. When I get 2 out of 2, the game ends. I cannot move anymore, but everything else still works. Right, so we have added coin logic and we have added score logic. Okay, now that we're done with that, I actually changed the background color to instead of the dark gray, I changed it to a light blue because I think that looks better. So if you open up our game right now, this is what it looks like. Our player can look left and right. It can jump, and once it's jumping, it can collect coins. Once we collect coins, you win, and you can restart the game. So if you press R while mid-game, you cannot restart it, and you have to collect all of the coins. You can play around with the levels, you can play around with where you place your coins and all, but this section, I'm going to be talking about sound effects, and this will be our second last section, and in the final section, we will package the game into a nice exe that you can ship. So at the very top of your game, you need to initialize some audio assets. So for audio, the first thing that you need to do, so like we did pygame.init, we need to do something called pygame.mixer.init. This lets us use sound features inside our game. And we can load a bunch of different music. So pygame.mixer.music.load, and let's load in one of our assets. So assets / music / background music .wav. And after we've imported this, then you can set the volume. So to set the volume, just do pygame.mixer.music.setVolume. And let's set it to 0.4, just 40%. I don't want it to be very loud. Then pygame.mixer.music.play -1. So this -1 basically means that you start playing this music and you just loop forever. So if I start the game, I should start playing the music and it will loop on forever. And it stops when you click exit, obviously. Next, you want to load in sound effects. So this audio is for background music. You can also add sound effects. So for sound effects, you simply just load in your effects. So I have an effect for jump. So jump sound effect equals to pygame.mixer.sound. And I will load in assets, music, not music, I think it's under sounds. And I will load in the jump.wav and jump sfx.set volume. I'm also going to set this to 0.4. I'm going to copy this down, and instead of jump, I have a coin SFX. So a sound effect that plays when I collect a coin. So coin SFX. And instead of jump, I believe it is just coin. So I'll delete this and I'll just do coin. But they don't play right off the bat. They need to only play when you're jumping and when you're collecting a coin. So you can change the sound effect of this volume. So I'll just set it to a bit higher than the background music. And all you need to do to play the sound is call this function. So wherever we're jumping, so I believe we were jumping somewhere over here. So this is where we're jumping. So as soon as we jump, I want to play this sound. So to play it, I just do jump sfx dot play. Simple as that. And when we're collecting a coin, so I believe we're collecting a coin right here, I just want to do coin sfx dot play. And I'll just play through the game and see if this works. Actually, another thing that I want to do is if the game ends and we're resetting the game, I want to restart the music track. So I'll just do pygame.mixer.music.play -1. So all this does is if we're in the middle of the track, it doesn't continue, it stops it right there and starts it from the beginning. So let's test it. You get the tracking sound. And if you collect, you should get the coin sound. You do get the collecting sound, but it's slightly low, so I might want to increase this to 0.9, and I want to decrease the background music further to 0.2. So you can play around depending on the music you added. And there you go. So I might want to decrease the jump SFX a little bit, and I want to boost the volume to around 2. There you go. And you can add music effects if you're hitting an enemy. And you can add music effects if you're hitting an enemy. You can add music effects when you die, when you reset your game, so on and so forth. And with that final section, we've completed this entire platformer game. Although in this video, we did not really go into depth about object-oriented programming or about animations on our sprites, I believe we made a pretty fun game, and this is a solid foundation to create other platformer games in Python. What you can try next is to create different levels. You can add more enemies, you can add more functionalities to your player, so like maybe shooting mechanics. And if you're interested in more Pygame content and you want to see a different game made or like a specific thing that you want to make using Pygame, please let me know in the description. All of the source code will be in the description. And I'll see you in the next section where we package all of this into a nice exe file that you can send to your friends, your colleagues, and run off the bat. Over the starting screen for winning and for game over. So simply just scroll all the way to the bottom right here, and right before you flip your display, I'll add this text. So at the very top, before we do that, we have this define some other fonts. So we want a big font where pygame.font.font. We set it to none, but we set the size to something bigger, like 72. And we'll have another with the size of 42 and name it medium font. And after you do that, I just copy pasted this block of code, and this block of code, let's go line by line. It says if game state equals to win, then we create a new window, which is an overlay. And we set the color of that window. We blit it onto our current screen at 0, 0. Top of our screen, we draw this window. And there's a message that says you win. And there's another message that says press R to restart. And we have these two things drawn on the screen. So if we play it right now and we collect both of these coins, if I can successfully do so, I collect one coin and I collect the other coin. It says you win, press R to restart. And I have a small overlay that is like slightly blackish overlay. And if I press R, well, nothing happens because we haven't added that functionality, but nothing in the background is moving. And this looks pretty nice. Similarly, for losing the game, I added another overlay. So if game state is game over, then it says game over and press R to restart. And this happens every time you touch an enemy. So if you touch an enemy, it's the same thing, but it says game over and press R to restart. So the game start and game end features are right there. At the very end, I want to add a function that actually restarts our game. So I'll create a function called reset game. I'm sure you're familiar with functions, but function is just a block of code that you can call by yourself. And inside reset game, I'm going to set some variables. So I'm going to get player rect. I'm going to get val x. I'm going to get val y. I need the on ground. I need my score. I need the current game state. And I also need facing right variable. So all that global does is that all of these variables, I'm not creating new ones. I just want to use ones that already exist in this file. That's all it's saying. Just copy along if you don't understand this. The first thing I want to do is player rect. I want to create a new rectangle. So pygame.rect at 100, 400, 40, and 60. Then I want to set the velocity x to 0. I want to set the velocity y to 0, so I don't want it moving anymore. I set on ground to false. Basically, all I'm doing is resetting all of the variables for the player. So I'm setting the score to 0. Game state gets replaced to playing again. My facing right is by default whatever it was, so it goes to false again. And for coin in coins, I need to reset all of the coins since some would be collected, some may not be collected. So I'll set them to coin collected equals to false. So all of the coins aren't collected anymore. So every single coin isn't collected. Right after I do this, I actually want to double check if this is my actual player. So I'll control F this. And when I created the player at the very beginning, I created the player at 100, 400 with 40, 40. So I have to create it with, in my function, with 100, 400, 40. It's not supposed to be 60, it's supposed to be 40. And it's simple as that. Now, at the very end, not at the very end, at the very top, outside this if scope, by the way, because we want this piece of code to run no matter what, if event.type equals to pygame dot, actually not right here. We just remove this. Let's check it at the very top right here. If event is quit, then quit the game. If event.type equals to pygame dot key down. So that means we pressed on a key. And if event dot key, so if this key is equals to pygame dot key underscore r. So if it's the r key and the game state is not equals to playing, the game either has to be game over or the game win. If either of those are true, then we can call it reset game. So you cannot reset the game mid play. So like while playing, you cannot reset the game. You can only reset the game if it is anything else than playing. If you press the R key, it is going to reset your game, which is basically calling this function that respawns your player, stops it from moving, sets on ground to false, resets your score, resets your game state, makes you look wherever you were looking originally, and then makes all of the coins visible again. So let's try this. Let's try deliberately hitting an enemy. And once I do that, if I press R, then the game gets restarted. Let's try winning the game and restarting it. So collect a coin, collect another coin, you win, and you can press R to restart. You can see the coins get reset, and our player gets spawned right back in. Creating the game, and you can go ahead and set your custom platforms, your enemies, your coins, and everything. And I've actually given you the tile sheet as well. So this tile editor, you can use this tile editor to, like, if you suppose you want to place a coin right here, you can see the positions where you want to place a coin by simply doing this, and it'll give you those positions where you need those coins. So it's pretty simple. You can do the same for enemies. You can try putting different enemies and such. But after you're completely done, well, one last thing that I want to leave you with is how to actually package your file. Sometimes your friends or like whoever you want to share this game to might not have Python installed on their device. Well, in that case, you can give them an exe file and they'll be able to run that exe file and play your game. So all you need to do is, first of all, pip install PyInstaller. So this is a package that we'll use to build your main file. Since I already have it installed, it shows requirements already satisfied. Otherwise, it will show that installing PyInstaller. Then you want to run PyInstaller --1 file. So it'll create one exe file. And you want to set the game to windowed mode. You don't want to set it to full screen because we're just checking for a cross button. And you want to give your file name, so main.py. After you give main.py, then it will start creating your main build file for you. And it should be done pretty soon. It depends on the speed of your CPU. And after it has completed, then it'll show you that the results are available in the Pygame tutorial list. So wherever you've stored it, it'll show it right there. So mine is right here. And if I go into the dist folder, I can see a main.exe file. Well, I can open this and play my game, but you'll notice that as soon as you open it, it gives you an unhandled exception in script saying that the assets, no file in assets. So that is because you don't actually have access to your assets folder. So one last thing that you need to do, so the assets folder that you had in your main root folder, so it cannot find that. If you simply just pull in your assets folder from your project root and drop it in here, once you open this game, you can play your game fully.